Well, yeah, it's like
Breakfast
the
is
whole time.
included only for conference day. It was not included in the day of workshop.
Workshop, yeah. That didn't start till 2.
Yes. We used to have a separate fee for workshop in the old times, but we no longer do this.
Oh, okay.
I don't think it's reasonable to take separate fee for workshop.
Well, the cost is fairly low compared to everything else, right? It doesn't cost that much, the workshop compared to the rest of it, right?
I can show you in a few minutes. I'll show you 2 examples. Then it's not. I will now get some breakfast and then I will show.
I got 2 more years actually.
Yeah?
In my 3rd year, that starts in September. And
Yeah. Nice. Like you see people using it. It's in search. Yeah, this might be research.
Oh, it's okay.
I feel like my research usually boils down to why did this break? When
But that's
Especially in the early days.
nevertheless.
When you were first
So
getting
where people learn.
I would imagine that very little on
Other
that
people
was
read
accessible
too.
then,
Means
probably
that
not much now. So is it just, you just do the screen reader and whatever comes out?
their knowledge.
Pretty much. Yeah.
I mean, what else is there?
What else is there? Yeah, exactly right. You saw this slide, the PowerPoint, and then also I think Norbert did a demo. That's how it used to be with maths. I have to make sense of that. But certainly since then, like 10, 15 years, we have still come a long way. Accessibility.
I mean, even if people have heard of it, just not the case not that long ago. I mean, there weren't 8 talks on accessibility at the TUG conference, you know.
In our school, we had 8 talks.
It was definitely a hot topic.
Yeah, so.
It surprises me. You know that Barbara doesn't know Expltools?
One more thing that
Did you know that Barbara doesn't know Expltools?
very useful.
It surprised me because, like, I don't know, I expected her to know everything, you know?
Well, you know,
It makes me feel better about not knowing things myself.
Honestly, like,
I've learned to deal with
I
it.
even use it for simple things like
That's,
I'll take my phone out, get my food, read
In the general circle of people I work with, it's very humbling because they're just too damn smart. So
you go out.
I don't try to argue points, but actually with people I work with because I'm gonna lose. Let's face it, if you're working in a circulating in a small environment like the university,
Oh wow.
you do not have to go very far to find someone who's so much smarter.
How many Nobel Prizes was there?
Yeah. Yeah,
Well, it's the UMA, so they have everybody.
I've never met this one professor, but Adrian and I were walking through Cab one.
I wanted to have a
And,
good, like, Japanese sushi because
Adrian knows this stuff.
everywhere I've
I
been,
wish I could remember his name. I can
every
look it up.
Japanese restaurant was
The point is, when it comes to
I didn't want
partial
that to
differential equations, sometimes you just
like, I'm quite foodie. I like making cuisine.
brilliant. Adrian thinks this guy is the most nice. Adrian's words were the smartest professor I ever met. And then a few of them floating around the
to mass secure knowledge. Pardon me? Or at least to mass secure knowledge.
What kind of fiction?
Oh, in time, science fiction.
Nice.
It's important to,
Like everyone has an ego. It's part of our.
oh, wait,
Part of
don't get
Say,
me wrong,
all
I'm
of
not
my
saying
top
egos
two would
are
probably be like
everybody needs them.
sci-fi or fantasy stuff.
Some people, I used to have a student who was
I
very
really like
argumentative.
classic fantasy.
He was a smart fellow. He had spent 10 years working as a writer before he came out of school.
Oh, yes.
He had a course.
Pratchett.
He had a very course.
I've tried Pratchett, you know, somehow he just doesn't do it for me.
Yeah, that's fair.
And just loved to run up against authority.
Song of Ice and Fire.
Yeah, I don't like those. I don't like those.
Because he was very,
things that he wrote.
as an iron worker, he was used to working with, but the point is he was helping some other students. He was teaching them how to weld, actually, which is the first thing. You're not qualified. Yes, I am. I have a ticket. Oh, okay. Oh, why are you using mine? You're welding already. This is coming from the workshop supervisor. And he said, well, did you pay for the rate? School. Well, this is not your welding. Isn't there? And just kept on going.
That's me as well.
She was always excited.
My grandpa was a mechanic. He taught me how to weld when I was young.
Ooh, there's a skill I've never, I've occasionally wanted to learn how to weld.
Usually audiobooks, but also
I've never really had
sometimes
access
if
to
it
it. I can find things from, you know.
Audiobooks are better, not even just because of like accessibility, but I can just put headphones on, listen while I'm cleaning.
Although, to be honest with you, I'd rather have a recording than cut it myself.
Every lunch, my wife.
Yeah, cut it like butter. However.
Do you usually read a book? Is it a library app?
Sandwiches for
That's what we have here.
It is.
This is egg salad. Yes, good. That's my favorite.
Oh, yeah.
I never read books because I stare at screens enough.
Yeah, that's fair. You know, one of the things, it's so funny, like smart glasses. So, yes, you know, they're working on these smart glasses now with AI. You know, there's so many great benefits to it. Oh, yeah, glasses.
I forgot to get you cutlery.
That's all right. I don't need cutlery.
Well, that's my little pea brain was sputtering on last molecules of sugars.
Starting to rev up for the day.
Yeah.
So,
Let's go with that. I like that. Sort of like an engine, you know, in a car that's been sitting in the garage for a year or two. Cross your fingers.
cold morning.
Yeah. You doing okay, Erik?
Yeah, the sandwich is actually pretty good.
Good, right on. I'm gonna move around over that one. You just stay put. I'm just gonna steal a chair this time.
It's easier to talk.
It occurred to me. No, go ahead. No, go ahead. I was just gonna pull a chair and chat this time, because him and I.
Hey, Carl. I saw you across the room.
Yeah, I saw you in across the room too. So,
I can catch you.
been introduced to the crew here.
I'm Tim.
Hi, I'm Nelson. Nice to meet you. Hello.
Oh, Nelson.
Jasper. Jasper, hi. Oh, yeah.
Yeah, good to
No.
see you again.
Oh, not bad. Hey.
Yeah, we had a brief chat yesterday.
Yeah.
Yeah, no, I keep walking past this fellow, and I go,
They know the name, but you walk past them. Talking about the advantages
But you have always had to grow up as a business, a social structure, entertaining. Yeah, well, that little app you sent illustrated for me 6-7 months ago where you would play different sounds in over Bluetooth, depending on what you were doing.
Oh,
Slides and camera is where you should.
Oh yeah, there. Testing, testing, testing.
Da 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 da.
Been complaining in chat, so. Already, so.
Alright.
And then I mean.
Good morning, everyone. It isn't quite 9, but you've got a minute and a half roughly to settle down and get set. We'll try to get started on time.
I think you could do the announcements, Nelson.
Okay, so just 2 announcements for this morning. The first one is that there's going to be a group photograph after lunch, and it'll be right out here on the east side of the building on this floor. The second announcement is some of you may have spotted their color photographs strung on strings at the back, kindly provided by Pavneet, who's, there he moved to. And anybody who would like to take one can take one or more, but only at the end of the conference. So some late tomorrow afternoon. Okay, I need to get, where is it here? So do we have a video queued up for? Okay. Okay. So our first speaker this morning is speaking remotely from South India, I believe. Rishikesan, or Rishi, began his journey with STM docs in 1996 as a typesetter. So that's 3 decades of experience. That's great. And it was here that he first encountered tech and related tools, which remain central to his company's production workflow. 3 decades on, he continues to be part of this same team. And I might add that at a previous TUG meeting some years ago, there was a discussion of what tech has meant for India. And there are hundreds of thousands of people involved in typesetting across the country, thanks to tech. Good. Cue up the video.
Hello, good day and greetings all of you. Myself Rishikesan T, together with Rajagopal, Apu and Rahul. I am presenting TeX and XML-based authoring tools. We are all working in STM document engineering Trivandrum. STM document engineering, also known as STM docs, was founded in 1994 in Trivandrum by CVR brothers to typeset academic research journals and books. And they have been using LaTeX for the entire production for the last 30 years. I joined this company in 1996. And this company, STM Docs, hosted International Tech Users Group conferences in Trivandrum 3 times. In 2025 was the last time. And we will be happy to host more conferences in the coming years if we get opportunities. And STM document engineering developed LaTeX-based authoring and proofing solution called Neptune, and which is widely adopted by the LaTeX author community. And they launched another authoring and proofing solution, which is an XML-based authoring and proofing solution, which is called Primo in 2025. This is all about the company where I work. And the main theme of this presentation is the role of authoring tools in the journal and academic journal and book publishing environment or world, where faster publication and greater precision and post-reduction are highly demanded. As what are the challenges we are facing, or what are the solutions to achieve all these goals for the publishers? We are actually providing some solutions in this talk. Main thing is speed. Publishers compete to reduce turnaround time for the journals and books. They have competitive advantage, faster publication. The speed directly impacts visibility and citations as far as the impact factor is concerned. So they always forces the typesetters to reduce the turnaround time in producing the output. So, as I said before, shorter production cycles are highly demanded from the typesetters. Publishers provide the LaTeX source files to the typesetting companies and outsourcing. Typesetters, the publishers do not have their own typesetting houses, but they outsource the typesetting services to companies like us. and but at the same time they are demanding a shorter production cycle, and from the typesetters, the standards and specifications are actually increasing day by day, and with every contract renewal, the cost reduction also is a main has also a very important role as far as the typesetter and publisher are concerned. If you look at the graph, you can see in 2000, 18 days were given to typesetters to produce an author proof. The remuneration was also decent. In 2005, it reduced it to 11 days, and 2010, 5 days, 3 days, and 24 hours in 2020, and 2026, it's again further going to reduce. At the same time, along with in line with the reduction in the turnaround time, you can see the remuneration was also reduced considerably, but at the same time, the specifications and standards have been largely increased. This is the current situation in academic journal and book publishing environment. See, on the right hand side, you can see a screenshot, the top and the table in the bottom. The screenshot, you can see an author has marked with a reduced space between the two variables like D and TO, the Greek alphabet TO, and 2 places marked, but in this manuscript, there were hundreds and hundreds of such occurrences. And in the table on the left hand column, the first column, you can see the bottom, in the bottom, you can see that author has used CMR fonts to create his manuscript, and the spacing between the variables was super, but on the right hand side, you can see the spacing is more spacing. This is not the typesetter's problem. This is because the publisher has chosen Stix fonts to typeset the math content in their journals. By default, the Stix fonts have more space compared to the CMR fonts. So this is a big problem for the author. So he has marked to reduce the space between these characters. So as a typesetter, it's concerned, they have to go and do it manually in many cases. And it is not at all a problem with the typesetter, but all the publisher's problem, because publisher has chosen the font to typeset it. So others are, without being aware of the changes, the others are always providing negative feedback for the typesetters. They have completely destroyed their paper, they completely destroyed the typography, etc. But as you can see, this is not at all a problem with the typeset. What publisher's expectation is that what author says, even if they have copy editing rules, publisher journal, publisher house style, etc. They say what finally you comply with the author. That's what the publishers say. So from the manuscript, typesetters are receiving from the authors to publishers. We have to not only create the PDF, but also we have to create an XML and MathML, which be completely well-formed, parsed or validated against their customized specifications. We have to create a high-quality, accessible PDF, high-quality print PDF, and everything in a very quicker turnaround time. And finally, the cost should also be in a very reduced. We have to do the service for a very reduced cost. Finally, author satisfaction scores will also be very high. This is what the publisher expects from typesetters like us. So what are the challenges in achieving all these things or meeting the authors and publishers' expectations? Some of the publishers' manuscript submission system is not at all organized or standard, and it is not at all standard to a certain extent. Authors can upload all the versions of their manuscript. They can upload multiple source files, duplicate files, etc. It is the typesetter's headache to sort out all these things and create a quality output in a very short turnaround time and a very reduced cost. This is the biggest challenge a typesetter is currently facing. It can be done as far as if for a non-tech manuscript, but for a complex tech document, this is not at all simple. to meet this challenge or to meet the goal or meet the expectation of the publisher as well as the author is not a simple task. And the content, many of the content the publisher, the authors are including in the manuscript, there will not be any equivalent mathML or XML tagging. So we have to take care of all those things and create a proper XML, proper PDF output without making any errors or omissions. Most of the tech files will contain complex tech macros, and handling custom LaTeX package is also a biggest challenge. These are not at all challenges if we just need to create PDF from the source files, but these are all becoming a biggest challenge as a problem, because typesetters have to generate some other outputs. In addition to PDF, they have to generate XML, mathML, EPUB, and similar deliverables they have to produce from the text source in a shorter turnaround time with lesser cost and with high quality or maintaining high typography. This is the biggest challenge. As far as the typesetter, for the last 30 years, I can say this. In the custom designed fonts, some publishers design fonts for their benefit to reduce the page number, to reduce the total number of page or page length. They design custom fonts. Sometimes others will not be happy. For example, they will be using CMR fonts, but at the same time, they are the final PDF or print of the published output will be in a different font compared to the CMR font. So the others will not be like typography. So typesetter's responsibility is to satisfy both the authors and the publishers. So this is a big challenge. Some non-standard typesetting template is another challenge, because authors will be using single column for the complex tech document with a lot of math equations and forwards and all. But at the same time, the publisher's typeset specification or model for that particular journal will be double column. So it is the typesetter's responsibility to break the equation semantically without making any errors. So here also the main problem is time. This cannot be done automatically. So this we have to input more manual work to do a perfect job without making any errors. So these are the typesetters challenges. And so all these specifications or expectations big impact on typesetters work. Balancing speed and quality is the biggest challenge. So to deal with the complex tech files, we have to give advanced training for the operators. We have to keep a very efficient support system who can look into the complex other macros and create a smooth environment for the transformation from a tech file to XML and HTML or other deliverables without losing the quality or introducing any errors. And the publishers expectations that typesetters should automate as far as possible, automate their workflow completely. But how can there are limitations for automation? We cannot automate 100%. We can do everything in an automated way. So there are still manual interventions required. So manual intervention means that we need more time. The quality cannot also be compromised. So these are all the big impact on typesetters when publishers are or others are demanding quick turnaround time and high precision and in a very cost-effective manner. So the proposed solution, we have some solutions to achieve this. If the publishers are unwilling to recognize the challenges outlined above, one of the following solutions should be adopted. For example, for the tech authors or the highly complex mathematical scientific journals where tech is one of the accepted manuscript source, publishers should provide authors a tech-based authoring and proofing solution, a controlled or standard authoring and proofing solution. Who need a YCB environment to compose their manuscript, an XML-based YCB authoring tool or a proofing tool should be provided. These are the proposed solutions to meet the all three goals like speed, quality, and cost. Text-based authoring tool. Text-based authoring tool, as you can imagine, text-based authoring tools are basically required for the tech authors and not for the word-based authors. In the authoring platform, authoring tool, authors should be able to pick a journal. When they pick a journal, that means when they typeset their manuscript, that manuscript should look like as in the published version. The font, the typesetting, the margins, the trim size, and the complete look and feel, and everything should look like as in the published version. So this can solve a lot of problems which the authors will or others will complain about if a different font and other things are actually chosen. So if there are any non-standard non-standard should be given, and more money should be paid for to handle these complex articles. And also educate others that they are typesetters or the publisher is not just going to print or create a PDF from the text source they are giving. Instead, they have to create XML mathmal for the future archival purpose. They have to create some other more deliverables from the text file. So they are and within a very shorter turnaround time, or a shorter turnaround time can easily be done for production of all these things. So these should be informed. Authors should be informed about these two, so that encourage others to use the authoring tools to meet expectations. So as a LaTeX authoring and the proofing solution, we have one tool called Neptune, which is developed by STM Docs. This has been launched in 2018, pre-COVID era. More than 1.5 million tech packages have been already proofed out, and author satisfaction score is consistently 95% over these years. And the many authors, from the feedback that we can see, they request the publishers they say all publishers must adopt Neptune. They have provided this feedback as a feedback to the publisher, as well as some of the authors have taken this or given this feedback in some of the social media as well. And the PDF produced from Neptune is actually completely in a journal default style, in which journal they have already submitted the manuscript. What is the final published version? That published version, their article is actually produced, and accessible PDF is also ready. No post-processing is required. They can, by default, accessible PDF can be generated. In addition to all these features, Neptune, there are some other features to Neptune, that is track changes. You can compare two text files, to versions of text files, to versions of PDF files. Version control is there. You can make some changes. You can keep a separate version, named version. We can reuse it, or you can restore the previous version, or use the latest version, whatever you want. So, and a lot of other features are there in Neptune, like you can you can accept or reject the changes made by the copy editor. You can answer the queries provided by the copy editor. You can upload new figures, new documents, etc. So if you want to know more about Neptune, please visit https://neptune.folio.org. So next is XML-based authoring tool. So publishers can provide an XML-based authoring tool for those authors who want a YCB authoring environment. It should be a standard XML-based authoring tool. And from the XML-based authoring tool, publishers can export quickly the XML, PDF, HTML, EPUB, or any deliverable that they want. They can implement their own validation tools, or their own compliance checks. They can implement collaboration, and version control can be implemented, and it will be an efficient and accuracy system. So publishers should definitely think about providing either a LaTeX proofing solution or an XML proofing LaTeX authoring solution, or XML-based authoring solution for their authors to meet the speed, accuracy, or typography and quality and reduce the cost. So for XML-based authoring tool, we have a tool called Primo. This is an XML-based authoring tool developed by STM company. We developed this in 2025, and it's in YC. It works in a YC. It has a YC approach, and from the XML-based authoring tool Primo, we can create PDF. But that PDF is actually created by TeX in the background, so we can assume how the quality of the PDF will be high. And in the YC environment, you can adjust the table weights, you can adjust that looseness, and you can adjust above below skips, you can adjust hyphenation, you can tie up two strings or string two words in order to avoid the bad breaking. For example, names, you can tie up given names and surnames which to avoid bad breaking, and you can do cross-reference of the elements, counters, and a lot of other features are there in Primo. When talking about the bibliography, you can import BibTeX database as such, or you can provide copy-paste the raw text of the bibliography, or you can type the bibliography details in a form mode or form-based environment. So all of these will be properly converted to XML and properly converted to PDF. To create an XML, you do not need any additional or post-processing. Then alternate images for the math content will be by default simultaneously generated. Publish, collaborate are available, and you can generate all versions of PDF, like the printed PDF, web PDF, and accessible PDF, track changed PDF, etc. You can be generated from Primo. Primo, currently one of the publishers and the European University publisher is using Primo for the last 6 months, and hopefully in this year, one of the prestigious publisher is going to start using Primo within a short span of time. Finally, conclusion. Speed is critical, but precision cannot be sacrificed. TeX is a powerful typesetting system with a programming-like capabilities. Publishers should understand that some of the TeX files are very complex. So when you demand a quicker turnaround time from the typesetters, please note that the complexity of the TeX article cannot be determined. The complexity, some of the documents contain huge macro codes or a lot of customized loading of customized packages, and a lot of complexities are there to produce the XML, EPUB, or HTML or PDF. It's really challenging. So publishers, while enjoying the benefits of TeX, publishers should understand the complexity of TeX documents and adopt a TeX-based authoring tool and encourage others to use it. And encourage others to use those who want a YC authoring environment. Please ask them to use XML-based authoring and proofing tools. And publishers, please not contribute and enjoy, help the community and enjoy the benefits of it. So thank you all, and that's all for today. Bye.
So, do we have any comments on the chat, or if not, from the floor?
Not in the chat so far, but
Not in the chat, then? Oh, question back there? Yes, go ahead. Oh, sorry. Okay, we'll use that one. All right.
You need both.
Oh, okay.
Just a comment. This is John Leonhard from MIT. I have used the Neptune system. I was delighted when the publishers introduced it. I wish it were the only workflow in use, and thank you for developing it.
He's still muted. Can you tell him he's still muted?
Oh, you're still muted. No, we can't hear you.
Hello, can you hear me?
Now we can hear
yes.
you. Thank you.
Yeah, okay. So, like you, many of the, we have many happy authors who use Neptune very efficiently and happy with the functionality and everything. So the basic thing is tech authors mainly want to see their manuscript in a tech environment, not like in a ICV environment or an HTML-based proofing system. So when they get a tech-based authoring tool, they are very much happy with it. Actually, the software, the tool Neptune and Primo was actually developed by STM Software Engineering, and STM Document Engineering is actually making use of the two products.
Good,
And,
thank you.
Thank you.
Other questions? Carl?
Hi, Rishi. It's Carl. I just wondered if you feel like you're the victim of your own success, that all these amazing requirements are being foisted on you because they know you can apparently handle anything.
Thank you, Carl. Thank you. Yeah. Yeah, that is actually the expectation from others, because the requirement, even for the workflow will be like a simple workflow, but the output, the quality, and everything the others demand is according to a high standard. So what we need to do is we have to spend time on it. We do not want to fed up the tech authors or the tech community. That is what we really want to do. So we always spend some time, and even if it is not required and that much quality is not required, but if the author has already requested for a high quality output, we definitely will do for them. Yeah. Thank you, Carl. Nice to talk to you.
Other questions from the audience? We still have a few minutes before we start the next one, but okay, if not, then we'll proceed with the next talk.
Thank you. Thank you.
So Vít Starý Novotný is due up next. And
Yeah, I can get it. I have to restart the slides anyways.
so need to do this one.
Okay.
Just 1 minute, I gotta get the slides up there, so yeah, no, just a minute.
At least we have extra time.
Yeah. Not yet, almost.
Sorry.
Should be good.
Should be good.
Oh, right. So good morning. Can you hear me? Okay. Is it picking me
it's on.
up?
Oh, it's flat. It's blinking.
Is it? It's blinking green.
It's fine. It's just probably too low.
Okay.
Or you may have to bend down a bit. Try it now. So good morning. My name is Vít Starý Novotný from the Czechoslovak Tech Users Group, and today I'm going to talk about some recent developments in the static analysis of LaTeX 3 programs. So static analysis is a way to find bugs in programs. Unlike dynamic analysis or debugging, this is done just by reading the source code of the program rather than actually running it. And ideally, we'd like to do this for all TeX programs, but TeX syntax is very minimal and dynamic, which makes static analysis difficult. By contrast, Expltools is a restricted and richly annotated subset of TeX, which is used for LaTeX 3 programming and which is more amenable to static analysis. Explcheck is a static analyzer or linter of Expltools 3 programs that has been in pre-production and development since 2024 and was first publicly announced on TUG 2025 in India last year. Also, a shout out to Canadian artist Greg from quickcartoons.com, which has been producing all the art and illustrations for the project. So Explcheck is part of the Expltools bundle, which receives approximately monthly updates and has seen some significant contributions from users. A special shout out to a Chinese user named Yukai Chao and my student Andrej Genčur from the Masaryk University in Brno, Czech Republic, who have both made significant contributions in the past year of development. And in the rest of my talk, I am first going to focus on the new features of Expltools since my presentation from the last year. Then I'm going to discuss the new algorithms that underpin these new features. Then I'm also going to conduct an experiment into whether and how well frontier and self-hosted local language models can mimic Explcheck and understand Expltools 3 code, and how well they can use Explcheck to automatically fix some issues in LaTeX 3 programs. Then I'm going to take a look at the roadmap and discuss why it's taking so long and what's there still to do before we can do the first stable release. And then I'm going to conclude with some parting thoughts and take questions from the audience. So during the last year's conference, we just finished 3 out of 5 processing stages: pre-processing, lexical analysis, and syntactic analysis. And we've started work on the 4th one, called the semantic analysis. And in the past year, we've finished the semantic analysis, and we've moved on to the last stage, which is called the flow analysis. So here's a list of the new issues that are reported by Explcheck that have been added in the past year. You may notice that there are pairs of issues highlighted in the same color from the semantic and flow analysis that have different identifiers but equal descriptions. And I'm going to discuss why that is in a short while. Previously, Explcheck would report the position of an issue, the issue identifier, and also the description of each reported issue, but this description was static and would often lack the context necessary to fix the issue. So following a suggestion from Ulrich Fischer, many issues now include a context that is, that is specific to each instance of an issue. For example, for the issue S105, needlessly ignored issue, the context would be the identifier of the issue that was needlessly ignored. For another example, for the issue E304, the context would be the unexpected parameter number, and for the issue W202, the context would be the control sequence name of the deprecated control sequence. So just something, some instance-specific information that give you more insight into what Explcheck thinks is actually wrong with your code. Although Explcheck has been designed to avoid type 1 errors and only report issues when it's reasonably certain, it may still produce false positives, or it may correctly report issues that you do not care about. Previously, you could add a special no QA command to silence issues on a particular line, like this. Or you could update your config file or provide a command line option to silence certain issues globally. And now, following a suggestion from Frank Mittelbach during the last year's conference, you may also write this no QA command at the top of your file, which silences these issues for that whole file. Separately, you may now also provide arbitrary configuration directly from the command line without being restricted to the subset of options that have a dedicated command line interface. And you may do this through the inline config option, which receives inline TOML content as its value. Arguably, one of the missing features of Expl3 is a standard mechanism for importing modules. In package code, this can cause Explcheck to report false positives for false positive issues, such as when a variable is defined in one package file and then used in another package file. To tackle this issue, Explcheck now supports what we call interfile dependencies, where package files from the same folder are automatically grouped and processed together. So this is just a heuristic. You may prevent this grouping or force it using the group files and no group files options, and or by writing commas and plus signs between the files which are supposed to belong together or not. And then Explcheck is more understanding about things like a control sequence being defined in one file and being used in another file, even though it doesn't have a great understanding of when the files are loaded from each other or what's the exact relationship between them. In the future, we'd like to have something more exact, but for the time being, this helps a lot with preventing false positive detections. Since its early days, Explcheck has included the Lua module Explcheck LaTeX3.lua, which distills information from recent versions of LaTeX3 files. Previously, it only included information from the files l3obsolete.txt, which contains deprecated and removed LaTeX3 standard library symbols, and also l3 prefixes.csv, which contains registered third-party prefixes. And these have been used to report, for example, the use of deprecated control sequences, as you may recall from an earlier slide. Currently, Explcheck also includes information from various LaTeX3.dtx files to determine the expandability of LaTeX3 standard library functions, which I'm going to also discuss in a bit. Separately, the LaTeX3 files are no longer taken from the current TeX but are pinned as a Git submodule. This is because previously, whenever there was an update to LaTeX3, the Explcheck LaTeX3.lua module would change, and we would get random failures in the continuous integration because some of the detections from Explcheck would change. So now it's more controlled. The continuous integration shouts at us whenever LaTeX 3 updates. Then we update the submodule, and then we expect there to be perhaps some failures which we fix. So it's much more controlled, and we get many fewer random failures from the continuous integration. So now I'm going to look at some of the new algorithms that support on some of these features. So the first one is code coverage, which is the ratio of what we call well-understood Expl3 tokens to the total number of Expl3 tokens in a file. If you take a look at this example, there is some simple text which is understood because it's just text. There's no complex material. Then there is the CS new control sequence, which is understood because it is part of a function definition statement. Then there is this example buzz :n control sequence, which is understood because it's part of an argument of the function definition statement that we understand and analyze. Then there are the curly braces, which are understood because they are part of the replacement text, which we analyze and understand. But then there is this unexpected control sequence, which is a part of an analyzed argument of the function definition. But that's just the top level. The code coverage looks at the innermost segment, and the unexpected control sequence is not part just of the top level segment, but also a nested segment that corresponds to the replacement text of the function. And within this nested segment, this control sequence is not part of any recognized statement, so it's not well understood. And computing the code coverage of this example file is left as an exercise to the listener, I suppose. This algorithm is used to prevent flow analysis for low confidence package files, so that we only use the more advanced analysis on files which we can understand quite well. Currently, there is a 95% threshold. So any package file which has code understanding or code coverage lower than 95% does not proceed to the final stage of the analysis. And as you can see from an analysis of all package files in TechLive 2025, the average is just 24% code coverage. So most package files just stop at the semantic analysis and do not even try to go to the final stage, because Explcheck just sees that it couldn't do the more advanced algorithms because it just doesn't understand a lot of the file quite well. In the future, we expect this number to go up, and as the flow analysis becomes more mature, we also expect this number to go lower. You can always override this in your configuration file and force flow analysis for your packages if you want to try it. This is what we also do in the continuous integration, where we want to catch bugs with the new algorithms. So we just run it on all package files and we look for assertion failures. But in production, the current approach is to just disable the flow analysis for anything that doesn't look like something Explcheck understands. So another interesting algorithm that has been added in the past year is the reaching definitions algorithm, which is used to resolve function calls to corresponding function definitions. We start from function definitions and then propagate them to all calls that they can reach. In this example code, you can see that there is the function definition of example bar, then there is the function definition of example foo, and then there is this function call which correctly resolves to the first function definition. Then there is the function call to example foo, which also resolves to the correct definition, but then there is this third call to example bar, which incorrectly resolves to this first definition. So as you can see, there is an issue with definitions within function calls. So this is solved by taking the standard reaching definitions algorithm, which is used for the more boring languages, and we just iterate until convergence. So in the next iteration of the algorithm, this function definition is actually seen, because after the function call to example.foo, the new function example bar is defined, so the final call correctly resolves to the correct function definition. And I mean, there's a sketch of a proof that this always converges. It still doesn't work for some function definitions which are for some more dynamic function definitions that are more obfuscated. But for a lot of function definitions, this helps Explcheck correctly determine which function definition each call is referring to. Then there is the expandability of segments, such as Boolean expressions or function definitions. In the semantic analysis, we first overestimate the expandability of segments just by looking which LaTeX 3 functions from the standard library are called from a segment. And by looking at the Explcheck LaTeX 3.lua module, we look at the expandability of these standard library functions. So this is just the first overestimate. When there are no standard library LaTeX 3 functions, we just assume that the segment is fully expandable. Then we weaken the estimate by repeating the following two steps. We take the replacement text segments and we propagate them to the corresponding function and function variant definitions. And then we look at all the function calls and use the expandability of the corresponding definitions to weaken the estimate of the expandability, and we repeat this until convergence. So this is going to make some segments which were expected to be fully expandable to actually turn out to be not expandable. There is a lot of uncertainty, since this is done during the semantic analysis which precedes the reaching definitions. So there's often there's a lot of uncertainty where a function call may have many potential function definitions. And in these cases, we just overestimate and consider the most expandable definition. So it's always an overestimate of what's actually the case. And then in the flow analysis, we use the reaching definitions to narrow down and further weaken the estimate. And this is also why some issues are reported twice from both the semantic analysis and the flow analysis, because if we can determine that a segment that should be expandable is non-expandable, or vice versa, early in the semantic analysis, we can report it early, and if not, we report it during the flow analysis. So that's why some of the issues are duplicated. So onto the experiment. So in the first experiment, the goal was to see how well LLMs can perform Expl3 static analysis. Here are the contestants. The baseline are just Explcheck's results. Then there are two self-hosted models from Google. And then there is also some frontier model from OpenAI. And the prompt is, you are an Expl3 analyzer. Then there is the list of issues the analyzer knows. Then there is a detailed description taken from the documentation of the Expltools bundle. And then it is asked to produce results in the expected quick fix format. And if you'd like to see the full prompt, you can see it under this link for reproducibility. So this is the example file, and these are the baseline detections. So there is some stream which is open but never closed. There are some missing stylistic white spaces before and after braces. There is an unused function variant. There is a second Expl syntax of which shouldn't be there. There are missing braces around the first argument of this function. So this is the output of Explcheck, and this is also what the frontier model reports. So it's able to perfectly mimic the expected output even without seeing the expected output beforehand. Sorry? So here is the result from the bigger self-hosted model. You can see that it misses some of the style errors around the white space. It catches most of the big ones, but it misses some of the smaller stylistic issues. And here's the smaller Google model, which just catches the fact that the stream hasn't been closed, which is quite obvious from the top level, but it incorrectly positions the issue. It works a bit, but not a whole lot. So in my second experiment, I was looking at how well the local language models can fix files using Explcheck's output. The contestants are the same as before. The prompt is, here are the results from an Expl3 static analyzer. This is the format of the results. Here's the file which are supposed to fix it. So this is the one-shot prompt. So I'm interested in how well it's able to fix it in just one attempt. And then there is also a feedback prompt where when there are some issues still reported by Explcheck, I give it back to the model and tell it, try again. Here are the issues which you weren't able to fix before. So the frontier model just is able to fix almost everything on the first attempt. You can see that it has correctly closed the open stream. You can see that it added all the white space which Explcheck suggested. It removed the second unnecessary Expl syntax off. It wasn't able to fix this issue with begin document appearing in an Expl3 block. But with feedback, it was actually able to switch Expl3 off and on so that Explcheck wouldn't complain. With the bigger self-hosted model, this also worked surprisingly well. It did most of the same things as the frontier model. The only thing it did differently is that it didn't stop the Expl3 syntax. It just added the spaces within the begin document command, which is arguably not as good as what the frontier model did, but it silenced Explcheck. And then there is the smaller model, and this was just an hour of pain. You know, it just went thinking about what is Expl3, what am I doing, and it wasn't able to do anything basically. So there is some threshold where the model, as much as it tries, it just cannot understand the input. Okay, so that was the experiment. Now let's take a look at what's taking so long. So Explcheck is currently about 2 years in pre-production and development, and the original project proposal expected 1 year of development, which was based on the expectation that all 5 processing steps would be roughly equally difficult. But this doesn't seem to be the case. As you can see, in the first year, most of the pre-processing, lexical, syntactic, and semantic analysis were completed. And in the second year, we just started with the flow analysis, as you may recall from an earlier slide. So the conclusion is that the estimate was incorrect because the project actually breaks down into 2 processing steps of similar complexity. The first processing step is parsing, which includes all the steps beside the flow analysis, and then the actual flow analysis. And each year, we complete 60 to 80% of one of these steps, and under this new estimate, finishing the flow analysis is expected to take another year. So the expected time of arrival for version 1.0 is perhaps TUG 2027. So besides the flow analysis, what's there left to be done? There are some feature requests listed on the project GitHub, which you can see here. There are also some caveats listed in the documentation. There's this big section which lists all the things that we should analyze, but we're not going to analyze before the version 1.0 because it would take just a lot of time. And there's a lot of important work in, for example, parsing key values and so on, but it's just out of scope if we want to make it at least in TUG 2027. But as always, patches are welcome. So if any of these feature requests or any of the caveats which you can find in the documentation, if they look important to you, then I'm happy to include them. Even before then, I just won't have the time to implement them myself, just because I'm trying to finish within the original scope. So in conclusion, the correctness of TeX programs is difficult to check. Expl3 is a language that is rising in popularity and currently makes up 10 to 15% of all TeX code in current TeX-Liv. Expl3 programs are much easier to analyze than with TeX. Expl-check is an Expl3 linter, which was developed as a part of the TeX Development Fund. Big thank you to the TeX Development Fund, as well as other sponsors, such as CV Rahul Krishnan from the Indian TeX Users Group, who have graciously sponsored the project, and also all the contributors who have reported issues or contributed code. Thank you. Expltools is a bundle which includes Expl-check and eventually other tools for Expl3 developers. The current version implements about 75% of the planned functionality. Currently, about 25% of TeX-Liv is considered well understood by the code coverage metric. The estimated time for arrival of the version 1.0 is sometime around June 2027, but flow analysis is only used for package files with large code understanding. So for most package files, the current version is essentially feature complete, and you should feel free to use it. And as for the experiments, frontier LLMs can reliably mimic Expl-check on small isolated files and fix issues from Expl-check, especially with feedback. And smaller self-hosted LLMs also seem to work okay in these cases. In my opinion, the ability to mimic Expl-check is not so useful because it doesn't really scale to larger code bases, but it shows surprising amount of understanding of Expl3 code, which I attribute to the regularity of the language compared to TeX. And the ability to fix issues seems useful, especially combined with some agentic tools, which would do this for you just by talking to Expl-check in the background. So that's it from me. Thank you for your attention.
We have about 3 minutes for questions, if there are any from the audience. Boris has one.
Yeah. Okay. I don't have questions from chat, but this is one from me. You say that LMs work on smaller files, but not on bigger ones. What is approximately the threshold? How big is the file that LM struggles with?
Yeah, I mean, I just experimented with this small example.
When does it start break? A couple of pages, 100 lines, 200 lines? Just as estimate.
Yeah, I don't have an intuition. I mostly code Expl-check by hand. So in the experiments, I just focused on the small files just to see what's possible and what's the best case scenario for LLMs. I expect to just get worse as you start giving it more issues that it can consider, because as you saw in the examples, I gave it an exact list of issues that it should report and consider. So you may expect that, here. You know, I just gave it like 5 issues, and here's the detailed description. But you can assume that if you gave it all like 150 issues that Explcheck considers, that would fill up the context of the language model, and it would be much more confused. And this would be combined with the larger package files. So I think it would be just overall much more lost than it is currently. So this is the best case scenario, I think.
Thank you.
Time for one more back there with the raised hand.
Hello, Matthew Scala here. I would be interested to know how the LLM mimicry compares when it is done with a different local model. In particular, the Gemma 4 models, I think, are not necessarily the best for this kind of thing. They seem to focus on personality more than on correctness. And so I wonder if another model, such as perhaps Qwen 3.6, might give interesting results.
Yeah, I mean, same answer as to Boris. I haven't done the experiments, so it would be interesting to see, but I don't have the results.
Fair enough. There are many interesting experiments that can still be done.
Good. We're ready to move on to our next speaker, Pavneet Arora. Pavneet has been around for quite a long time. And a number of years ago, we had the pleasure of attending a meeting in Toronto that he hosted. We had a wonderful time, and it's good to see him back here.
Thank you. Thank you. Don't mind if I'm going to run a little late. I've already done. As Nelson said, it's really nice to be among old friends after such a long time. Those who've known me for a long time, or even short time, know that I like to play with words. And so this talk is both about workflows and designing workflows for engineering documentation, as well as engineering those documentation workflows. It's a double entendre. My standard disclaimer for all my talks is there is nothing new here. And Carl is, for that reason, placed me right before the break, and those who get bored, coffee is served. There's also quite a bit of material to cover, and I'll be skimming over the majority of it. Or as my late grad school roommate Selvaraj used to say, just skip the gruesome details. And I'll probably end up talking like Alvin and the Chipmunks at double speed. My interest is in engineering documentation, in particular specification-driven documentation. So I'd like to quickly run through some of my talks, the topics of my talks, not to bore you with nostalgia, but just so that you can see, like I have begun to realize, that they were just steps along a long path. To begin, in Boston, I spoke about this workflow which related to project estimation. YAML was used for specification, LuaTeX for output, and I had standardized on a model view controller framework with TeX and the associated utilities for the view. Then came Tokyo, Tansu. Tansu was, I used John's very excellent asymptote package to create interactive 3D wire models for cabinet layouts like you'd find in kitchens. And YAML was used to store both the vendor catalog of cabinets and the kitchen design. And of course, the day before the conference began, I made a fatal mistake. And not for the first time. It happened on this conference as well. I initiated an OS upgrade, which completely bricked my asymptote demo. So there I was, adrift in Tokyo, scared and alone, looking for a fixer. And I found one. And he wasn't Yakuza. The man in the corner, Norbert, not only was one of the hosts of Tokyo, but he was the package manager for asymptote, for Debian. So I chased him down in the hallway. That was my introduction. Norbert, you may not remember. And he pulled from upstream, saved the day. Next was Sutra in Portland. It dealt with documenting signals. And I mean signals in the systems theory sense, not just in the electronic one. You know about the playing with words. Five Eyes was a nod to Five Eyes, the alliance in happier times. Most documentation deals with the first two, identity and interface. Since that time, I have focused on adding the bottom three into documentation workflows. Sutra came about because I was trying to diagnose this boiler system and really struggling to map out the network, the electronic controls, the piping, and whatnot. And I took inspiration from something known as the Noguchi filing system, which I implemented in context. And I've experimented with many, many non-linear scroll documents, as Jean-Luc Demont calls them. So, in summary, I'm interested in how do we capture information, how do we organize it, and how do we communicate it? Simple task. And for those who may not know the 1960s anthem, what is it good for? The rejoinder was absolutely nothing. So yesterday, Erik spoke about the generosity of the tech community throughout the world. And Corey and I spoke about it just this morning. So let me tell you a little bit about my own story. I arrived at TUG 2010 not knowing a single person. Other than Carl's warm emails accepting my naive talk topic, I have had no interactions with the tech community until that point. To say that I was intimidated would be a severe understatement. Like at the 10th anniversary that Barbara spoke about, all the Stanford tech luminaries were there. Professor Knuth gave his very famous talk of E-Tech. And I had barely a few scores of successful LaTeX compiles under my belt. So during the talk I gave that year, which was about mathematical literacy, I mentioned my love of nomography and alongside other calculating devices, analog and digital. I returned back to Toronto and was immediately overwhelmed with the cut and thrust of daily responsibilities. A short while later, a package arrived in the mail. And in that package, amongst its contents, was this. It's a flight slide rule. Boris, I don't know whether you remember, you sent this unbidden to me. That is the generosity of the tech community. And I think the kindness and generosity is what will sustain us in the future. Okay, so let's begin with discussing document creation. Documentation creation is focused on implementation of engineering system. It's rarely, if ever, worries about usage. And what it means is the audience are the various trades whom are usually siloed, and they're not talking to each other, never mind the people who are going to end up maintaining the system. The end result is a mishmash when you really want a proper man page that describes the behavior of the system as it was commissioned. So here are some of the challenges faced in documentation documentation creation. Access matters. When you are confronted with a system like that, and maybe you can't even access the back of it without destroying it, you better be very, very careful. Scale matters. We'll get back to this project later, but if the system's large, complexity is added. I don't have the photo here, but I'll show it to you later. Safety also matters. You'd be surprised at how this enters into documentation creation. So the consequences are you get inadequate end-user documentation, and like its namesake, incendiary explosive device, you have to handle it with care. And we need risk mitigation for when we create documentation. So what we need is the equivalent of the dry run flag in rsync, because as I'm sure all of you know, if you swap source and destination on an rsync -- delete, you are in big trouble. So the best way I know of gaining that knowledge is an audit, an engineering audit. Okay, the next couple of slides are going to look like a McKinsey PowerPoint from 2001. I apologize. Touting the virtues of clicks and eyeballs, but just bear with me. They do have real-world implications. Base requirements, capture and verification, and judge efficacy as efficiency and utility. Now, before we get to know how an audit fits into documentation toolchain, I want to touch briefly on a core concept to its creation. Some of you may know of Adam Savage. He's a special effects creator and host of a very popular YouTube channel. That's not how I know him. He came up with this idea and concept which has gotten really good traction, called first-order retrievability. This explains it a little bit more. Essentially, you shouldn't have to move a tool out of the way to be able to access it. I look at it a little bit more broadly. Here's a counterexample. This is my late father-in-law's toolbox. Yes, you may have to move a thing or two before you access it, but it worked for him. Amongst the trades I know, this is more common, and this happens to be one of my maintenance pouches. But how do you achieve first-order retrievability? Before you get to retrievability, especially with information capture, you need transcription. So only transcribability can lead to retrievability. And here I'm using first-order retrievability has a prime mover, that being first-order transcribability. And I'm using it in the engineering connotation, the initial force whereby natural energy might be converted to work. Corey can tell us if I'm still within bounds of using prime mover in the classics Aristotelian sense. Without transcribability, retrievability is wishful thinking. It does not happen automatically. So this is what I call a transcription surface. Start with the project. These are electrical panels mounted on a roof high above the suspended ceiling tiles of a restaurant inside a luxury hotel. The concrete floor is, if I remember correctly, 20+ feet above the ground, which was filled with all expensive furniture and whatnot. Here's another one. So I took these photos while standing atop a 10-foot step ladder, and by top, I mean the very top of an A-frame where it's imprinted, do not step. One hand hanging on some of the cables that hang on to the grid. Talked about safety matters for documentation creation. Case in point. So this is remarkably well labeled by the electrician. Most electricians will not do this. Unfortunately, it's completely devoid of the information that's needed. Here are some of the problems. Yes, it has in situ labels, but there are 3 different electrical panels in different parts of the restaurant, which means you have to go up and down to try to make sense of it. There's no physical topology or anything like that. It gets even worse on the control side. Controls have hard addressing, soft addressing, load mapping. None of that is there. So what's to be done? What then must we do? I came and did an audit. And I did the addressing. I mapped all the light loads, the panels, the hard addressing, the soft addressing. Vít, you may recognize the pen. I picked this pen up in Kutna during one of the context meeting excursions. It's standard issue, I'm told, for engineer, or at a certain point, for engineering students in the Czech Republic. It's a Koh-i-Noor 4-color pen. So after I'd done all the initial lighting scenes, a lighting consultant was called in to tweak the scenes. When he saw my notebooks, he could not hide the disgust. Don't you use Excel? It would be so much easier. No doubt he was left wondering what form of computer illiterate had been hired to program this system. I'm not here to convince you that an analog approach is preferred, but I hope that through this talk, you, like me, might at least question the path dependence of digital only. This slide also has an interesting artifact because it demonstrates prior art. In engineering, prior art is important. You need to know version history, and you certainly can't do that with Excel. It may look rudimentary, but it's very helpful, and it ended up being so. The lighting consultant kept asking me, well, for that light load, which intensity levels have we tried? And I could just show him. That's the progression. Useful. So what is a transcription surface? You've seen the analog part. It's an analog input form combined with purpose-filled markup. Essentially what we're doing is creating a microgrammar that allows you to go seamlessly between system verification in the field and a suitable data representation feeding downstream processing, i.e. documentation workflows. It should serve the audit function upstream where time is a very tight constraint and human resources are at a premium, while still having sufficient structure, sufficient syntactic sugar to be processed by machine. I introduced this topic at a context meeting in Dreifelden, and my submitted title was the second one, and Raban kindly pointed out that if I was going to have illusions or pretend to have illusions of German, I should at least get the correctly gendered definite article. So he corrected that for me. All right. We're all familiar, I think, with tabular and hierarchical, but input form type topologies can come in different, with other topologies. For instance, large facility control systems, this is a relatively small one, will use daisy chaining with T-taps to connect up certain devices in the field. It would be far too expensive to home run everything the way we're used to with Ethernet. I think most of us have forgotten about Token Ring, which was a T-tap topology. These chains span out radially, each on a separate link or bus, hence the title, Wheels of the Bus. The purpose of the transcription surface is to recover the information gap between design and implementation. This is an active process and not just simply a passive one of capture. By necessity, this requires inquiry, observation, reasoning, validation. The questions to be asked are, what input form serves the purpose and constraints best, and what can we do with it afterwards? So let's take a really big example. I showed you that panel, the panel room. That was one of 11 panel rooms split across 2 buildings and 5 floors. Not 5 contiguous floors, but 5 staggered floors. A really big deal. And I had introduced the idea of live system risk. Well, I hope you can see that this is very real when you're the person responsible. And this is the documentation we get to work with. You have lots of blanks. you have this metronome of phase, ABCD, which is ABC, which is useless. For some reason, you're given line numbers, which no one will ever refer, alongside load numbers, which you might refer. You've got duplicate nodes or leaves of the tree, and the real information you need are in the ... dots, which means that the report is completely useless. So what you've got is obscured information, duplicated information, missing information, overloaded fields, no contextual notes. You seem to have the sniffles. Let's do an audit. In our house, we have a running joke whenever anyone's under the weather. You seem to be showing signs of being under the weather. Let's start with a lumbar puncture. We were fans of House MD, and in every episode, for whatever reason, Dr. House would say, let's start with a lumbar puncture. Tight constraints, we talked about time and human resources. Bar and restaurants open till 1. Residence lobbies are open 24/7. This is multi-building. There's a luxury residence building attached to this hotel. And these residents are very unforgiving to disruption, as you can imagine. Hotel light duties. We have to do the work between 2300 hours and 5 o'clock the next morning. This may be obvious to most, but just in case, observed light requires darkness. You have to flick lights on and off to identify light loads. People notice, and you have to do it in order to find out which light connects to which circuit. There's also this issue of comms blackout areas. We as guests only see front of house. Here it's small, but in large hotels, there's a whole back of house. Subterranean caverns of workshops and housekeeping and whatnot. They are not provided with cell phone boosters and all of that stuff. There are areas where there is zero signal. So the audit process can be broken out into different elements. I break it down into these 5. The first 2, capture and engagement, form the core. I put delegation and verification together because with these large facilities, you are inevitably going to be relying on teams to span out and help you verify things. And finally, we have abstraction. We are still trying, while in the field, to resolve inconsistencies, attribute function, and motivation. Arish spoke of this yesterday, but I promise you, I've had this slide for months. In my experience, analog input has many benefits, not the least of which is learning about the subject matter through writing. And those who are interested should most definitely do a deep dive into Zinzer's books, and this one in particular. Delegation verification. Don't always assume connected. So as I mentioned, hotels don't spend money on cell phone repeaters in the back of house. So what we ended up doing is actually from that very panel room, we ended up doing a fire brigade. And equipment rooms are noisy. So I was inside the equipment room, someone is at the door, down the hallway, there was another relay, up the stairs, there was another relay, and then the team had phone signal, and they would span out to do verification in the field. And the signal would come all the way back. Again, analog can prove useful. The other thing is team members don't have in-depth system knowledge. They have other knowledge, which is really valuable, but not necessarily system knowledge. So the transcription surface format has to allow for that, because you're going to delegate this. I long loved this quote by Dijkstra. Some people find it helpful to start with a theoretical and then apply it to the concrete. I learn better by confronting the empirical and abstracting patterns from it. Okay, choice of markup. Rishikesh and others have talked about XML. It's well known. Long-form documents have such well-defined input representations. However, they can burden the document markup so much that they prevent direct editing. And keep in mind the time constraints and the resource constraints we have to deal with. Ah, yes. We're all familiar with the human readable part. We rely on markup so that machines can process it, but that choice is an artificial one. It should not be biased solely on the processing, which is for the machine, but in our case, we have to bias it towards a human for the capture of the information. And so human readable is a throwaway phrase, but I would say it's a very low bar. Supposedly, this is human readable. I can understand evaluates a determinant. The rest is Klingon to me. It's APL. So purpose-built markup does put a burden on having to parse the markup by yourself. But there are well-defined tools that can give you an assist. Here's an example of just a small bit of microgrammar. So the way this was done was I designed the microgrammar. We did it analog, pencil and paper, and then we did a text file. And you can see there's a little bit of notation there about the load. And there's other elements of it. And then we would take the printed version, enscript it, send it out in the field for verification. And this is the legend. And before we begin, Barbara, Carl, I'm so sorry, there's a spelling mistake. Verified is misspelled. I can assure you this was an early version when the screenshot was taken. It did not hit the final report. But I want everyone to notice this part. We actually took note of this. Handwritten notation on printed light load table or on painter's tape. Sometimes a technician will put some note on, on the breaker with painter's tape, just the way we have there. They have tried their best to add to the institutional knowledge of the system when the institution itself has no clear structure to capture that information. The audit allows you to do that. So this is again just the same light loads with the notation, something that the maintenance staff can understand and sustain the system in the field. Okay, we're back to terraforming now, or we're not back, we're now terraforming. Another site, another bunch of electrical panels. You've seen this. This is a luxury retailer. Holt Renfrew has a store down there if you have unexpectedly come in to the lottery. There's a slight issue with the system. There are no keypads. Or I should say more properly, there are only keypads in private shopping change rooms. The whole store, not a single keypad. Sounds like a simple problem. There are issues. Lights are burning 24/7, whether they be interior lights, exterior lights, signage, display windows. Not good when you're advertising that you're trying to hit sustainability targets. One is forced to use breaker control or a button-operated menu to change the lights, switch lights on and off. So I was asked to program into the system, and there are 3 different systems across this store, time clock events. And I thought about it, and I went back to them, and I said, you know, that's really dangerous, because if the lights are off at night and emergency services are called in, there's no way to switch the lights back on. Risk. More constraints. This time we're only given 2 hours in the morning, and that time is shared with staff who do store cleaning, display prep, staff meetings. Standard audit, DNF, do not find, decommission, possibly. After the audit, we proposed to the client a control system acting as a single sheet of glass across all 3 processors, and I'll explain that in a little bit more detail. The desired features are local operation, offsite operation, time clock events. The distilled functionality, basically all you want to do is you want to set the light level somewhere in the field or get the light level and display its state. Now, I can already see those people who haven't gotten bored. Your VMs are spinning up behind your eyes. Docker, Podman, Nginx, Apache, Postgres, Mariah, Flask, Laravel, you know, the full gamut. LibSocket, or maybe, you know, Carl and I probably still have our copies of W. Richard Stevens network programming. We're thinking, oh, we'll just do it in C. Let's just pause for a second. De-risking. 2025 Free BSD Dev Summit, Michael Windsor. Alpha Omega is sponsored by the Open Source Security Foundation. He focuses a lot on de-risking open source software, open source dependencies. The idea is to minimize dependencies, and so on. I'm partial to an earlier expression of the same idea. It's known as Chapman's Law, and car enthusiasts may remember this. Colin Chapman said when he was designing his Lotus sports cars, simplicate, then add lightness. I can't think of a better way to engineer software. So then what is terraforming? We started with the transcription surface and a markup, analog and combined. Can we use it to create an end user application, the same transcription surface? Well, we know it served the maintenance staff, but can it now serve the operations staff? And if we expand the use of the transcription surface to serve two different constituencies, and we simply aggregate them as a set of sets, well, we know that ends up in Russell's paradox, right? Maintenance staff need detail and depth. Operational staff need simplicity and clarity. So what is required when we're trying to design a control system out of that same transcription surface is additional semantic layering that has nothing to do with the electrical topology or even the controls topology. And I called it grouping. But let's just revisit the hierarchy. Into the processor, you have a panel and circuit. From the processor, you have this idea of floor, room, load, and zone. The problem is some loads may not be attached to the same processor. So operations staff doesn't care. They don't want to log into 3 different systems. The site reality at the project that we're talking about was highly non-conformant. You had a split level grate, so even the concept of floor doesn't exist. Interior, exterior, mall interior, back of house. So this is the nomenclature I came up with. Light loads belong to areas, areas belong to department, departments belong to districts, districts belong to building levels. Notice nothing about the processor or the bus. So here, I just took a screenshot. This is it in action. So for instance, women's wear, colored similarly, and it extends below, can consist of non-contiguous areas on the retail floor. Curtain grazing down at the bottom runs along the whole perimeter of the store, and because some of the floors are mezzanine, they span both floors. Software approaches considered. Hand-tooled, sorry Norbert, vibe-coded, not a chance. What we settled with, transcription surface. Remember, I standardized on MVC whenever it was, 2012. Some of us are, I'm not going to say our age, some of us might have been members of LCIS, the Library of Computer and Information Sciences. It was like a book of the month club for nerds. You'd get 3 books and you were allowed to evaluate and return the ones you didn't want. I remember when this book came in, Unix Relational Database Management by Manish, Schaffer, and Jorgensen. It was like mind-blowing to me. There is an open source project called FSDB, which purports to take some of the ideas of /RDB. I couldn't make it work, and I ended up using CSVKit. Okay, configuration, model part 2. It may seem ironic since I've spent so much of my early time talking about YAML, but I adopted RCL. If you take nothing away from this talk, more than this, do a deep dive into RCL. Ruud van Asseldonk wrote this very excellent and biting article about the YAML document from hell. So what is one to do? He, of course, writes his own config language, which is a superset of JSON, very elegant with control structures. I used RCL for color palettes to be complementary, other CSS, JavaScript snippets. Now, another anecdote. There's a wonderful craftsman that I worked with who was also a great teacher, Frank Ropos. And he was the kind of person you would imagine having found in Zen and the Art of Motorcycle Maintenance. His fastener cases were very counterintuitive. He would, you go to a Home Depot or whatever there is, you see them all row sequentially up or down, right? Half, 5/8, 3/4, 1 inch, et cetera, et cetera. His fastener boxes would have sufficient differentiation across adjacent cubbies so that it could never mistake one for the other. He would never put a half next to a 5/8 because it's too easy to mistake. Similarly with color palettes, it's important to have that differentiation. Semantic layering, we've talked about this. The grid layout and processor bus details were all stored in RCL. Quickly go through the view, the rest of it, Lighty, Lua and minimum CGI wrapper, static HTML. Going back to de-risking software, in recent years I've taken great inspiration from static site generators. There is no need to build this huge complicated edifice atop a CMS for it to come down crashing at an inopportune time. The front end work, I got a lot of heavy lifting by my cousin nephew, Bart Chauhan in New Delhi. He's a great open source developer. If anyone is looking for someone talented, reach out to him. Controller was a self-contained Lua app with local modules tree, again, de-risking. Okay, let's revisit models part 3. We have to talk to the processor. As much as I would have loved to pull Stephen's book off my shelf, I just needed something reliable. Expect scripts do that. They work all the time without any fuss. Here's a sample of the telnet session. Looks all very straightforward. There are some wrinkles to be had with level, fade, delay, and zones. So let me show you that. All right. Zones are decimal at the processor. API, they're hex. This is fairly trivial because it's a one-to-one mapping. It gets a little bit more interesting with intensity levels at the processor, like when we do the audit, 0 to 100%, human readable, API still 0 to 7H. Similarly with fade and levels. So what's one to do? My gratuitous Unix command. This is a DC that converts reported intensity hex into percentage. Now, I put the comment down below because I find it freaking cool that DC is the oldest surviving Unix language program, and I am using it to solve a problem in 2026. And I can only imagine what Lorraine Cherry and William Morris must think or have thought if they knew it was going to be embedded in if they included an embedded system. This is OpenWRT because we're given access via a general building automation network with lots of promiscuous devices on it. So I put my firewall. This is FreeBSD on a Celeron N100 running Ujala, the application. Okay, quick demos. I hope this worked. This was a test of the expect scripts. And, oh, this is great. You got it in loop mode. Excellent, thank you. And then this is with the floor plan view, what the operations manager would see. And the effect is a little bit washed out, but Barth had done some undulating. The status of the zone or the department is identified with that. Okay, conclusions. Using transcription surfaces gives consistent and very effective results in creating engineering documentation for as-built reality rather than as-designed plans. But there is so much more, much, much more. By decoupling input markup and document markup, we can also create parameterized applications or terraforming, if you'll indulge me. And if there's errors in the original transcription, it's a simple matter to modify those and go through the full life cycle, generate documentation, as well as regenerate the application. there was no manual intervention to what you saw in the demo. Finally, the added semantic layer can be combined to create end-user documentation, even after the application's written. I'm going to skip this part, but you may see that this is not a typical Beamer package. It's because when you're wearing transcription surface glasses, you see everything as a nail. So I wrote my own markup, and this uses LPEG in context to generate these things. I talked about this a little bit in another talk, context meeting talk, Zettelkasten for non-digital nomads. This is how I wrote this presentation even before I had written the software. All right, one final story, the epilogue. If you'll, I know, but just give me 30 seconds. I ask your indulgence, if that's okay. Those who want to go for coffee, it's outside. I began this talk by saying that there's nothing new here, and let me drive that point home emphatically. On this continent, it is mandatory for all children to visit a Disney property. And if you fail to do that as a parent, you will be marked for gross negligence. And not only that, the relationship between your children and yourself will be ruptured, and any setback they face for the remainder of their life, they will point to that trauma. I resisted for a long, long time, but then finally accepted with one condition. If we had to make the trip to Orlando, we would also have to allot one day for Cape Canaveral. During the visit, we signed on for a bus tour that took us through the history of NASA's various eras. Near Launchpad 39B, I tried to explain to my kids about the extreme heat those ceramic tiles had to withstand. No interest. My son was doing parkour over some of the displays. My daughter is dreaming of the pool back at the resort. Kind man came up to us and talked to us. He talked about how cooling was done in the shuttle engine. He was a propulsion engineer on the shuttle program. Final stop was Apollo, much diminished because for people of our generation, Apollo looms large in our imagination. I was out of patience with my kids. The kids were out of patience with me. We went our own separate ways. I was reading the description about the Lunar Command Module. My daughter runs up to me, Papa, there's an astronaut. Now I had in mind some actor, great for kids. He can engage with them. So dressed in full regalia, whatever. Papa, you have to come now. He's about to leave. I said, okay, I'm still trying to process this, right? Like, why do I need to see Buzz Lightyear? I know the kind of story, right? Then she said the most dangerous words for us in this audience. He was signing books. Well, I followed her. She's running, with her pixie legs as fast as she can. I'm trying to move quickly without creating a security incident. I didn't want to be tackled on my way back to see what she's talking about. So I went back to see what was happening, and indeed, table was there, boxes were packed up, the gentleman was leaving. Does anyone recognize this, and in particular, whose handwriting this is in red? Anyone? I know I'm out of time, and I've indulged you far too long. This is the handwriting of the late Commander James Lovell of Apollo 13. This is part of the 75-page checklist that he annotated along with, and I've forgotten the astronaut's name, who was left behind because he fell sick. And they collaborated to bring the crew safely home. To me, there's no better example of a transcription surface. Yeah, the stakes were pretty high then. So all I can say, I forgot. Last prop. This is the book he signed for me that day. So you're welcome to look at it. We would all do well to look up at the sky once in a while and imagine the possibilities. Thank you for your indulgence. Sorry for taking this.
Thanks much, Pavneet. We'll break. There won't be time for questions, but you can grab Pavneet in breaks. And we'll
Boris,
get
I
back-
know. Here's the book.
My son-in-law is bad labeling and stuff, and it starts when you're trying to build stuff.
Yeah.
Hello, good day and greetings, all of you.
So hello everyone, and
Hello, everyone. Thank you for Hello, good day, and
So hello everyone.
hello, good day, and great.
So hello everyone to my overlooking deck where Mrs. Kennedy sat,
Oh,
where
I see.
the late Queen Elizabeth sat, and other kind of great world leaders. That was left completely intact, and that's actually where you get this. In the
Same seat, yeah.
Where Her Highness was
Yes,
sort
yeah.
of presented with. So hello this is everyone what these to my newfangled Americans are doing, and so on and so on. Yeah.
Okay, our first speaker. Our first speaker of the second morning session is Clemens Lode, who is a software developer from Germany. He wrote a book called How to Publish Your Book with LaTeX, and he reports that his frustration with long recompile times led him to build a real-time LuaTeX editor that he'll present today. That sounds rather interesting. Clemens?
So hello everyone to my talk, Real-Time LuaTeX Recompiling Large Documents in 1 millisecond. I'm Clemens Lode and I'm the founder of Lode Publishing, and Conor Craig is the editor. The big question is, why yet another LaTeX editor? So the market is filled with LaTeX editors, but in my special case, so Lode Publishing's primary business is typesetting and proceedings, and we constantly have projects in LaTeX with more than 800 pages. Recently also proceedings with thousands of pages, and working with the common LaTeX editors, including Overleaf, etc. It really takes a long time toward the end of a project, polishing, really clearing up the white space in a project. And this led me to developing LaTeX templates first for books and proceedings. But that got me only that far. There's also no InDesign-like program for LaTeX book typesetting. It's really stuck in this batch compiling of TeX files. Artificial intelligence opened some doors in a few recent years to get a better understanding of deep LaTeX internals that maybe just a handful of people know, at least concentrated in the world. And also because of my background in operations research and evolutionary algorithms, and some discussions on Reddit and some back and forth about the upcoming Typest editor, like basically one of the rivals of LaTeX these days. And because of my background in building user interfaces for optimization problems, I decided, okay, hey, maybe I give it a try. And really, maybe the last actual motivator last year, I questioned all my life choices when Overleaf moved the chat button. So I really had one extra click each time I discussed open issues with my editor. So eventually I thought, okay, I can do better. I can build something that is really focused on my use case. So reduced recompilation times for very large projects. This speed versus quality trade-off I discussed in my last book last year, published this year. Back then I still thought, okay, we have the advanced typography algorithms in LaTeX, and that is only possible if you really compile the entire document separately in a separate compilation phase. And you have, on the other hand, Word, which is real-time, but it uses simpler algorithms. So I assume there's a trade-off between speed and quality. From like UX design, human interaction with the computer, we know that like anything under 200 or 100 milliseconds feels instantaneous. Better probably like below 20 milliseconds to really get that like 60 hertz refresh rate. Up to 1 second, well, there's still an uninterrupted flow of work, but at like 10 seconds, so if you move your mouse and it takes 5 seconds or 10 seconds, like the program is lost. So you lose attention, you get frustrated. Anything like beyond 2 minutes, it's okay again. if the program tells you it, because you say, okay, I'll grab a coffee while it's compiling. And what is missing is, of course, like a high quality software that stays below that 100 milliseconds threshold. Prior attempts to bridge this gap, it's ongoing since at least 1995. So sorry if I missed a few items here. So that's just what I found or what I knew. So it's 1995 with LIX. It has a structured preview, but it still needs like the batch LaTeX for the final output. We have in 1999 the GNU TeX Max. It's a true what you see is what you get, but it also delivers its own engine, so it's not really TeX compatible. In 2002, 2003, depends on where you put the year, you have Bacoma TeX. It is more like also what you see is what you get editor, but again it has a modified engine, so it's not like vanilla TeX. In 2012, people began with software as a service. Back then Share LaTeX and Write LaTeX, and that was combined later in Overleaf. There you have all the standard engines, all the standard LaTeX, and it's fully compatible. And their approach was, okay, let's focus on collaborative editing and let's focus on the whole server landscape. So you don't have to care about installing LaTeX or switching different versions. You have the compatibility, but of course the actual compilation still runs in one run and relatively slow. 2014, you have KTeX. It's in the browser, JavaScript based. You have fast math rendering, but it's not really a full typesetting system. So it's similar to TeX, but you can't like run any TeX file. Plus, it's not 100% pixel perfect compared to a clean batch LaTeX run. 2019 with Swift LaTeX and BusyTeX, that you have like WebAssembly solutions. So you solve the issue of servers that you need, separate servers you need. You run the whole thing on the user side, but of course the user still has to download the WebAssembly, and you still have to do full compilation runs. In 2023, you have TeXpresso and Tectonic. It's a modified CTeX engine with a fork. So you take snapshots, so you don't have to recompile everything that was unchanged until the paragraph or chapter you were editing. And of course, the limitation is Linux and Mac OS. You can run it with VSL in Linux, in Windows, but of course, it is a limitation. 2023 also start of TypeSt. Incremental compilation with memorization. So you focus on the question, if I change something, what other parts of the document are affected? So you reduce the amount of things you need to recompile. It is not TeX compatible, faster than a standard LaTeX compilation. So you don't have like to call LaTeX 3 times and to get all the references right. But as we see later, it does scale ON, meaning larger documents, longer compilation times. I will address this a little bit later. So what I saw in 2024, 2025 is there's a real market gap, sub 100 milliseconds, O1 compilation time with an unmodified LuaTeX engine. So my initial approach was, okay, I know in LaTeX you have include operations. You can use include only. You can cache individual chapters. You can include PDFs, so you don't have to recompile everything. You can cache that. With LaTeX MK, you can check whether files were changed. And this was my first approach. So you can do faster recompilation of larger documents with some caching, but it wasn't really where I wanted to go. And so really the question was, okay, how fast could we theoretically go? Really, if we ignore all constraints, let's see how fast is LuaTeX or LaTeX in general really. So I did some benchmarks for the real technical limit for recompile times. So I measured individual paragraphs of different sizes, over 500 compiles per category, all with like full microtypography, open type, shaping, and reached the verdict, okay, short lines, just 0.17 milliseconds on average, long lines, 2 milliseconds as a medium, and medium lines, 0.7 milliseconds. Obviously, you can here argue, well, a chapter theoretically could contain just one single paragraph over many, many pages. So you always have like no maximum in terms of recompilation time. But really my focus was books. And for books, usually paragraphs are around 4 to 5 lines. So proceeding with 0.7 milliseconds, I thought was a good starting point, like as a lower technical limit. Obviously, those compilation times depend on the CPU. We just use a standard laptop. So in theory, LuaTeX is fast. So there's no like, okay, it's slower than this or that, or it takes a long time. So it is really, really fast, and it can render updates at 60 hertz or more. Also, of course, I tested, okay, is there like a degradation over time if I recompile 500 times, so it really works here, it stays the same. I did see a few LuaTeX bugs that there were some fonts accumulating due to some rounding errors, but those are fixable, so it's not an issue. So the question is, okay, is this enough? Can we really say LuaTeX recompilation is 1 millisecond or 0.7 milliseconds? First, the Knut Plus line breaking algorithm is paragraph local. So it doesn't matter what other paragraphs contain. The paragraph itself, it's limited, and the algorithm applied to it is also limited. Also, editing one paragraph does not change the line breaks in another, obviously, and boundary cases like footnotes, references, also those affect page breaks, but not line breaks. Also, the user obviously edits only one paragraph at a time. There is a case to be made, okay, if multiple people edit the same document, but for my use case, okay, one paragraph at a time. So we can summarize the smallest organizational unit in LaTeX is a paragraph. And only the edited paragraph needs to recompile per keystroke. So if you type something, you don't have to check again the bibliography or the other chapters. You only have to apply the changes to a single paragraph. And this is, I mean, this is nothing like revolutionary. It's like Word or InDesign does it. It's like most other editors do it. They just recompile a single paragraph. Still, I mean, it sounds simple, and some of you might now be motivated to try it yourself, just recompile a single paragraph, but it soon feels like in Star Trek, the motion picture, where you have like this old technology in the middle and like an entire ecosystem of tools around it. So my approach was to put like a vanilla LuaTeX in the center and put all the wiring around it instead of changing the central core unit. Obviously, LaTeX was never designed for this. It's 50 years old, and 50 years ago, real-time editing complex math equations was not really the focus of it. And with every new package I look at and test, there's always a little bit of fighting going on, especially for algorithms that are actually including like page breaks or something like that. As an additional challenge I put myself was to build like a real client-server model. So networking puts additional latency to the whole thing. Let's look at a demo now, because that's why you're here. Okay, here you see you can drag and drop RUB fix, and you see the same time you're dragging or changing something, the LaTeX data adapts, like left and right, or the sizing, or just moving around. You can also add, obviously, some tables. Here you see writing in real time the columns, column names, nothing special except for the fact that it's real time. We'll add some content, so you see how the paragraphs work inside the table. I'll just copy it here from below, just adding a number of cells here. In the output, of course, you see it's not yet a paragraph, so I will adapt this in the header. So now you see, well, it's updating. Now you see a paragraph, or in paragraphs, so with line breaking, 1, 2, 3, and you can in real time adapt the widths of the individual columns or cells. Of course, you can also move it around. Here you see a quick demonstration of the highlighting, so it's also in sync with the text editor, and there's of course a 2-page mode, so you can, like, what you see is what you get, directly type it, so you don't even see LaTeX. That might be good for beginners. There's also like an inspector panel where you can directly adapt the font, and in the LaTeX you see here it's surrounded by a particular style, so similar to, let's say, Webflow, where each style gets an own ID. Here's a very, very long document. I just took one from arXiv, and here you can see me just scrolling through it. So it's a lot of equations. They're originally from PDF text, so they don't translate 100%, and the author did some customization, so it's not a 100% conversion, but at least the equations are there and the text is there. So let's scroll through it a little bit, and let's pick, let's say, a random part here, and here let's just type in here, and we can also write here. It's a little bit slower, actually. I'm working on this a little bit, so there are some issues with very, very large documents, but I'm working on it. Previously, I mentioned tips and why it is 01. So I ran also a few benchmarks here. The same medium paragraph, 4 to 5 lines with typed watch, over 30 edits, and warm up, of course, excluded. So it's just the focus of the compilation for better comparison. And you see, like, with 10 pages, it's super fast. It stays below 20 milliseconds. But as soon as you get like 100, 300, maybe 1,000 pages, you see an increase. And this increase is also reflected in additional versions. That means the architecture of TIPS moves into a different direction, moves more in the direction of features and correctness of the entire compilation, and not in the direction of, okay, let's make it faster, let's make it faster, let's make it faster. My approach was to keep it for all sizes of documents constant. I did some research, like what's behind it. I'm not that deep into the typed architecture, but it really is ultimately a design decision. I mean, you can probably change the architecture a little bit of types to make it real time. Also, I'm convinced that eventually I could just replace in my own editor to say, okay, switch between different compilers, switch between LaTeX and types, and you have that as the core unit, and you can then also achieve constant constant length of each compilation. And from the creator, for the question, okay, could we do like a partial evaluation for huge documents? There's a separate types issue, and at least in 2024, the judgment was, okay, it is not feasible. Ultimately, I think those are different like target audiences. For example, types does a lot of batch compilation of many different documents, while my focus is really like a single large document where you add a lot of small edits, especially towards the end, when you move things around, when you edit small things that you don't have to wait each time 2 minutes until you see the result, just because you like moved a little table left or right or increased the width of a figure or image. So my point was really, let's do it like InDesign. I really want to see the final result of my change. One interesting thing or one interesting thought that came up for me while working on it is like this could open a lot of doors in the LaTeX development, because a lot of features like are on the horizon in typesetting, but have not found their places in the LaTeX development. For example, there is no real algorithm to do a float placement over the full book instead of just going page by page. So you can't really have optimal float placement with the current page by page compilation that LaTeX does. Same like optimization, when you have a book and have 2 pages in front of you, you can't do an optimization that the 2 pages look good. So you have to go page by page. Also, there is an option like for similar avoidance to improve like penalties for line starting or ending with the same word. You can apply then river avoidance better if you can recompile. Also possibly like variable font justifications. And in general, I could imagine that all those different parameters like badness, looseness, also you could apply evolutionary algorithms to optimize each page to look good, because you can recompile quickly and see the result and adjust it a little bit, and then after a few seconds maybe, or just partial parts of a second, you have an optimized value for each paragraph or each page. So that I find exciting for future developments in that field. You can get a hands-on demo in the Frankfurt Book Fair, of course in Germany, if you fly over or if you're already attending. I'm at booth F97, hall 4.1. And the focus there is more like on the proceedings side, like really large documents in the proceedings field with thousands of documents, PDFs, etc., and combine that into a LaTeX document. And there you can bring your own tech project, and we try it out. How does it look in real time? How you can edit it in real time, and then just give it a go. Feel free to mention the TUG talk, and then we can chat a little bit. Alternatively, go to TechLoad, sign up for the waitlist. I'm still figuring out a few things, but it's close to starting a beta test where you can try it out for yourself. So thank you very much. Full details of the benchmarks are available in the preprint. I also have the benchmark scripts for types and for LuaTeX. You can test yourself. And of course, as mentioned, sign up for the waiting list or drop me a line. Thank you very much. And now I'm looking forward to your questions.
So I see 2 hands up. Did you? Yeah.
Thank you. Didier Verna speaking. I don't want to monopolize the mic, but I have 2 questions and a comment. First question, I'm curious about the round trip that you have between the WYSIWYG interface and the source code. And for instance, when you graphically adjust the width of a table and the dimensions are repercuted in the source code, what kind of level of syntactic or semantic analysis are you doing? Is that hardwired in your engine? What would happen, for instance, if the table was generated by a macro coming from a package somewhere?
There could be, I mean, I am currently testing one package after the other. So you could imagine that you can break this system in any way by introducing a package that does something with the page. So because my focus is really the individual paragraph. So the worst case would be that I say, okay, the entire page is a paragraph. So the worst case would be like a paragraph that takes like 30 or 40 lines. So you can multiply the 2 milliseconds again by another 5 times. So you would end up like with 20 milliseconds per time.
Okay.
Date.
Okay.
And for the macro expansion, for certain packages, for example, you have seen the Preflight, where I moved around the image. So I actually had to re-implement some of Preflight to get it working, because again, it's a package that isn't like one single paragraph. It's overlaps several paragraphs.
Okay. My second question is the following. I have trouble understanding how you can remain within a constant complexity if a paragraph is changed in such a way, for instance, that the number of lines increases and all the subsequent material has to be moved, invalidating reference to page numbers and stuff like that.
Right, so you don't see those other pages in an editor. So it's a different paradigm in an editor versus the batch compilation. So in a batch compilation, you have to go through everything. So you have to recompile everything. In an editor, you have the advantage to say, hey, the user sees only the current page. So yes, maybe on page 340, an image will move down on another page or something like that, 100 pages down, but the user doesn't see it. And until the user scrolls down to that page, there's enough time to calculate that move.
Okay, thank you. I understand.
So the real issue is you have to combine the editor with the compiler.
Okay, I understand better now. And just a very quick comment about the stuff that you say. The slide was entitled, "What if paragraph justification could be done in less than 1 millisecond?" You mentioned a number of things like similarity avoidance, for instance, which is something I did a couple of years ago. And my opinion on this is that everything that fits in terms of design in the original Knuth Plus, in other words, everything that can be naturally expressed in terms of penalties or demerits and does not disrupt the general flow of the algorithm, is not going to be so costly after all. We could discuss that, but that is my view on that. Thank you very much again.
Thank you.
I have a couple of questions from the chat. One question is how does it perform with complex layouts, like multi-column layouts, tables with row and call spans, etc. And the second question is whether it's a customized version of LuaTeX or standard version.
For the first question, so that aligns a little bit what I said at the beginning for the other question. The worst case is that I have to take the entire page in. And if the 2-column layout is in the way that I need to know the next page before I can calculate the current page, that's of course even worse. Especially for the two-column option, I am working on a solution, but currently it is then simply accepted as, okay, this is one paragraph. So if it contains 20 lines or 30 lines, then you have that additional 10, 20 milliseconds because I have to do the entire paragraph new. Similar to the table that I've shown, if it's like a table that covers the whole page, then I have to recompile the first column, the second column, the third column. For the second question, that was, what was this one again?
Whether it was customized version of LuaTeX.
Oh, right. So it is not customized. So like I said with the, so it's standard TeX Live 2025. What I did was building a lot of wrapper around it. So it doesn't work with PDF tag. It doesn't work with CTEG. It only works with LuaTeX because you can really get into the compilation of each page. So that is the main difference. But I don't need to deliver any other LuaTeX engine for that.
Hi, thank you. This is Max Chonoff. So my question is, how does this work? Like at a low-level technical level, what are you doing to make this possible?
It took about. The main idea is really what I've said about the paragraph. And you can imagine that I'm not restarting LaTeX with every time I do a paragraph recompilation. So basically everything you see on the screen is cached. So there's a cache for everything. And that is sufficient to bypass all the recompilations. And that is something that, again, isn't supported by PDF tag, isn't supported by CTEG, but if you look deeply into LuaTeX, this is possible.
Okay, thank you.
Okay, we're a little short on time, but we'll allow one more question here.
You said you don't have to rerun bibliographies. What do you do if there's in the paragraph a new citation which isn't yet called in the bibliography or in the bib file, in the BBL file?
Right, so I said I did an unmodified LuaTeX. I did it's also a wrapper around the bibliography, but actually the bibliography I have to rerun. So this is separate from that. So that's a problem I haven't solved yet. I would have to actually rewrite Biber for that to work. So you basically get the result then with a delay.
Okay, thank you very much. I think we have to move on to the next talk.
Thank you.
Yeah. You doing the presentation? Yes. Okay.
How do I do it? Okay. Thank you.
So our next talk has an interesting title because it's reversing the process. We've seen the output. What did the input look like?
Okay. Thank you.
Try to turn the mic on. Just press the button. The handheld one. Hold the bottom, it's right at the very bottom.
Now just press here.
Ah, here. Okay.
Did it turn green?
Yes. Yeah. Can you hear me?
Yes.
Okay. Usually, people in many other professions don't talk about, I wouldn't say failures, but the work which did not work as expected. We scientists and engineers love to talk about our problems, maybe failures, and try to find some teachable lessons from them. This is a work which is still being done. It does not, our preliminary results, and I will say it from the beginning, were not what we expected, but I think we extracted some very interesting lessons from this. Okay, I think it's, okay, other way. So, you have, let's start with this. What you can see here, this is Book of the Dead. This is papyrus from ancient Egypt. You probably don't know Egyptian enough to read this, but if you look at it, you see, okay, there is a 3-column typesetting, there is a text in black and with some words in red, and it's split into paragraphs, and each paragraph starts with eye diagram. It's a bird, and it's a big eye diagram, and you'll say, okay, probably it's each paragraph is a chapter, and probably the bird is as the name of this chapter, or maybe they are going to describe this bird, and maybe the red text is some important words there. Okay, next example. This is actually a book of Psalms. It's from about 1500. It's made in Krakow. It's very beautiful book with a lot of multicolored things, with a lot of interesting beginnings. But again, if you look at this, you will say, okay, I probably can split it into parts. Each part starts with a big letter. Some letters are red, some letters are black. Maybe they show me some subdivisions. And again, there are some red letters, which are probably something, some important words, and so on. Of course, some of you might know Latin and might recognize the book of Psalms, and you will see that you have seen the beginning of Psalm and beginning of the verse on the Psalm. But even if you don't know Latin, you probably have some idea of the structure, right? Here's another thing. This is deck. And again, you might know TeX or might not know TeX, and you might know or might not know what's written here, but you can see that there are some paragraphs. Some start with bold text and bold numbered text, and you probably see that this is some subdivisions. And this is actually exercises in the book. And again, you might know, you might not know what's written here, but if you look at it, you immediately see the structure. So we have, I think that humans are very good in understanding visual cues. Humans are very good in looking in the page or several pages and say, here's the structure of my document. But there is an important caveat, if they can see them. And as we know from the first day of this conference, there are many people who don't see this, and we want to add with the cues instead of usual visual cues to make them to understand this. And we have spent a lot of time talking about tagged PDF project, and we know that the idea is to take the LaTeX text, add tagging, and create accessible result, accessible PDF, for example. The thing is that it's very easy to add cue to something like section, X, subsection, paragraph, or subparagraph. But what happens if you see something like this, like large BF series, or something like centering, or so on? What if you see a visual formatting. It would be very difficult to tag PDF project to understand what's going on and add the corresponding logical cues. And how important is this? Well, we looked at the arXiv papers. There are a couple of percent of arXiv papers which use visual formatting for section like headers, but much more for lower levels. Like if you have math, you have step 1, step 2, step 3, and you would want people to use something like enumerate or something like paragraph or subparagraph, but most authors just put some visual formatting there. So you would want to be able to recognize this. And our big motivation is related to another project you already heard about today, about arXiv reprocessing project, when they wanted to have most of the old papers, reprocess them to make it accessible. And again, our question was, what happens if you have only visual formatting? So we decided to create some system which will take visually formatted LaTeX text. And because we were thinking about arXiv reprocessing, we start from a source, not from PDF, extract logical information, and go on. Now, what is the biggest problem with machine learning? It's not the lack of resources. We have now much better resources. It's not the lack of algorithms. We have a lot. The biggest problem in machine learning is the lack of labeled data. You want a lot of data to teach your machines, and you want it to be labeled if you want machines to have the same understanding as you have. And it's very expensive and very difficult to make people to label. There is a trick, we invented it some time ago, which is this. If you have already structured data, you can make it unstructured, but it will be labeled because it's structured from the beginning. Okay? We did it with the BibTeX citation extraction project. We wanted to have a lot of labeled citations, and we just took structured BibTeX data, ran it through different BibTeX styles, and got a lot of textual information with different ways of formatting. And then we said, we asked machines to find out how to go back. Here we decided to do the same thing. We took a logically formatted papers from arXiv, I will talk about in a second. We ran a special obfuscation script, which took a paper and randomly, but consistently within the paper. So basically, before I started the paper, I started to say, my sections will be large, BF series, or my section will be just uppercase, or something like this. My subsection, and so on. It decided it randomly before starting processing papers, and then processed some visually formatted papers, and this was our training set. And again, we were because we started with what we knew was correct logical formatting, we knew what should be back. So here is our pipeline. We took 120K papers from arXiv. We obfuscated all of them. We trained a model to restore it, and then we compared the results with what was from the beginning. We used BERT. It's the standard transformer model, and we used a couple of open source LLMs which we tried to fine-tune with papers. Because we have labeled data, we could fine-tune them. What we used for evaluation, we used basically the difference between our ground truth, what we started from, and the results of this double process, obfuscate and go back to origin. And if we are absolutely right, our results should coincide with what we started. And we had a couple of measures. We have string distance between the result and ground truth, and so-called Zheng-Sasha distance, which is basically if you have a tree of sections, subsections, and so on, what is the difference between the ground truth tree and the tree you had? And the results were disastrous. Basically, what we got was completely different from what we wanted to have. And we have spent several months trying to do something with this, and we never were able to restore the structure as we wanted. So we are still working on it, we still have some ideas, but our preliminary result is that no, it doesn't work. It's something which you as a human are very good at doing, and machines, both transformers and the modern AI, seem to struggle with. So maybe we are not going to be substituted by cheap AI, at least soon. Okay, because we are scientists, our next question is why? What happens? Why people are so good at this and why machines are not so good? And here is our hypothesis. How do we do structure? And the idea is that when you think about structure, you first look at the document as a whole. You don't read it. You just glance through it and see, okay, it's what I have shown you in the documents. Let me get it back here. You see, you look at this, and I, by design, I made it not very, not big resolution. I don't think you can even read Knut's words unless you struggle with this. You see something as a whole. After you see something as a whole, then you start reading, but you already have some table which says, here is how my visual formatting corresponds to logical structure. But this is the part you do first. And if this is, and we actually have something to confirm this, because when we discussed this research with the reviewers, it was rejected from document, but we still have some ideas of what to do. They showed us the paper, which actually was very good and at looking at logical structure. Unfortunately, we didn't do this from the beginning. And the way the paper did it, they started to read paper and started to build a tree. And whenever they found something different, they said, well, maybe this looks into, maybe it fits in the tree, maybe not. And the idea is that you already have a local thing and you have global things. And you need to combine this. In our research, what we did, we put chunks into models paragraph by paragraph. And I think this is what actually made this not work, because you cannot understand the structure if you read it paragraph by paragraph. You need first to look as a whole. Suppose this is right. What can we conclude from this? First, we understand that humans decipher visual contents using change of the focus. But it has a very interesting implication for tagging and for accessibility project. Because one of the questions I have been asked when I talked to different people about tagging was this: why do you need so much effort? Cannot you just make screen reader tell people about visual formatting? So screen reader, instead of saying section introduction, would say boldface, large, introduction, and boldface, all and large. so on and so on and so forth. And now I understand why. And the reason is that when you process your information linearly, like you do with screen reader, instead of being able to look it visually, you cannot actually easily understand the structure. So I think the decision of standards committee, PDF standards committee, to put logical structure rather than visual structure for accessibility was right decision. I don't know whether they had experiments working with this or just had understanding of working with blind people, but it was a really good decision. Now I understand why. And the other thing that if you want to do logical deciphering of the logical structure, you need to do some focus change and some attention change, and you need to be a little bit more sophisticated than just putting your text into AI paragraph by paragraph and telling AI to find out some structure in it. So that's what our work was about, and I'm happy to answer questions about it.
So we have questions. Yes, I see a question back there, and then we'll go to Norbert for his question.
Hi, my name is Charles Stats. I was just wondering, did you try doing something like this with sort of modern, one of the very recent models that has tools added to it so that it could, read a substantial portion of the document and then has a tool that lets it go back and reread particular portions that it might find especially interesting, because that's sort of standard now.
Yeah, when we start, we did not. We used thank you, thank you. When we started last year, we did not have this, and we did not. But it's very interesting. Yeah, that's what we are going to think about. But we worked with standard at that moment Llama, open source Llama models. But it's thank you. It's very good question. Very good suggestion.
Norbert Preining here. Did you check with Elm AI? Elm AI did something very similar, like, I don't know, 8 years ago. They have drifted away a bit, but they have done exactly like this, trying to get the structure out of an image of a PDF with a blob. Might be interesting to see what they have done. I think this is still available in some way. That's the one question, as a comment just. The other, you said we, the authors, was in which setting did you do this research? I was interested in.
Okay. Thank you. Thank you for the comment. It's great. It's a great hint. I will look into it. About setting. UMass has a very interesting program which is called Industry Mentorship. What they do, they take a postdoc, they take a group of postdoc or graduate student, they take a group of students, and they find people with interesting problems outside of UMass, and for certain credits, they try to solve this problem. And it was second time I worked with UMass on this. So basically, my co-authors are from UMass. They are beginning researchers, and one of the things I wanted to say is that they're absolutely great. In both my bouts working with them, I was really surprised and impressed by them. But this is a great program, and I hope that other universities would do this because it's a very interesting thing to take some real life problem and ask your students as your projects to do this.
The initiative was from the Zuckerberg Foundation.
Excuse me?
The initiative started from the Zuckerberg Foundation?
No, yes. Well, yes and no. I worked at Chan Zuckerberg, and they contacted me at CZI, but it was more personally that it was not sponsored by CZI, and the sponsor of computer time and everything was UMass.
Sponsor arXiv, please.
CZI sponsors arXiv a lot, and I think that you start.
Besides Google, none of the big players dedicates a single cent to arXiv, just to mention this.
Hello, Matthew Scala here again. Further to the question about using tools to reference earlier in the document, I hope that something else you'll try will be just using your existing approach with a model that has a larger window.
Yes.
Because today we have even very small models that have very large windows.
Yep.
And I think that could well be enough to make it work a lot better.
Yep. Absolutely. Absolutely. I think that our biggest mistake was to take paragraph like chunking in the beginning. I think we have had resources to do it larger, and we should do it. And if you see research where you didn't make any mistake, show me.
We'll have time for one more question, and then we'll have Norbert up here.
Charles, that's again one more question I wanted to ask. How carefully did you clean the data to make sure that you weren't including documents that, for instance, had inconsistent usage of the sectioning, so that maybe they either didn't, your training data might have started with documents that either didn't use sectioning commands or sometimes use bold instead of sectioning, which would have made it very difficult for the model to learn anything.
Yeah. Very simple. I must confess that we did very simple criterion. We ran obfuscation script, and if obfuscation script didn't change anything, we assume that the paper doesn't have section subset, so on. But the thing that somebody used both visual and logical formatting on the same level never came to us, and you are the first who say this, but knowing some offers, yes, this is possible. This is possible. Offers are evil people. Thank you.
Okay, thank you very much, Boris. Our last talk of the morning is Norbert Preining again, who will probably tell us more about arXiv.
Again.
Oh, I'm sorry. Yeah, I didn't want to steal it.
No.
Thank you.
Yeah, hello everyone. To my second talk, again on arXiv, not surprisingly, about arXiv processing. If you have seen my talk 2 years ago on arXiv, that was very early when I joined arXiv. You will see a lot of not repetition, but the changes that happened since then. So But I want to introduce two things that we actually develop also as open source, a kind of quick, we call it Preflight parsing, a parser of whatever is thrown at it, as tech code, and a dockerized compiler, which runs all our compilation at arXiv nowadays. Okay, I just have the slides in, but you have seen them the last time, so I skip over them because it's anyway. Yeah, that's maybe interesting. So for arXiv, we try to be open with everything. So we have open science, that is very important, like everything is open and accessible, including the source code of 90% of the papers we have. That was a great decision by Paul Ginsberg, who started back in '91. We're still grateful that he started to collect the sources and not only the PDFs, because we can now actually also produce the HTML, as I told yesterday. Open source, we use a lot of open source tools. We contribute a lot of open source tools. Maybe yesterday that came over a bit unclear. So the new Rust rewrite of LaTeX ML was not by me. That was by Dejan Ginev, who is also the maintainer of the Perl version, one of the maintainers of the Perl version. So that was not my work. I just want to make this clear. And we also, yeah, so LaTeX ML. And then, well, open access, about accessibility, I talked about a bit yesterday. There's much more to say. A bit about arXiv. So we have tech documents from over 30 years. To give you an idea, we have like 90% of our submissions are LaTeX. There are plain tech, there are AMS tech, there are, well, we have docs. Also, we have some Windows doc, also WinWord, that was permitted, I don't know, 20 years or 15 years ago for some time. We don't do this anymore. PDF data is generated, is considered generated. That has a history because we had not enough disk space, so we deleted old PDFs that were not requested for some time. We stopped this practice because it's a bit of a pain, but still we want to be able to reproduce and recreate all the PDFs at any time. We had till, let's say, 1.5 years ago, until I took over, we had a lot of additional packages shipped. Mostly those that publishers don't put on CTON and don't put in TeX Live. Then we have my most beloved time bomb Jonathan Fine package writer. Those who know laugh. It's not fun. If you want to recreate a paper from 10 years ago and then it fails because a certain person decides, anyway. Not to speak of all the contexts that authors are doing. That would be a separate talk, just examples of really bad TeX and LaTeX code. Anyway, we keep documents, as I said, compilable, and we compile them with the origin. We have to compile them because otherwise they would probably fail or not also fail completely or look completely different. So we compile them with the original version, which means at the moment we have TeX 2 and 3. I mentioned this yesterday, so this is very old. And TeX Live, we have at the moment this list here. So for just a funny side effect, TeX 2, we have only 32-bit binaries. That is nice on your computer if you run Linux, because 32-bit emulation is automatically enabled on most of the Linux distributions, but not in the GCP cloud. So there is no 32-bit emulation on GCP. So you try to run a 32-bit binary, and this doesn't work. So we have to use QEMU to run 32 bits to run TeX 2 and TeX 3. Not the funniest thing, but it somehow works. It's not only TeX, it's also like DVIPS and Ghost Script and yeah, a lot of stuff that hangs around behind there. So the past at arXiv was a system that was called AutoTeX. Again, as I mentioned already yesterday, it was written, okay, I don't repeat. So a Perl system like over the last 30 years. There's a super old version on CPAN. Don't try it. It's super tightly coupled with our submission process. It does magic detection of the format by reading 5 lines. Hopefully that works. Especially if you have %- at the beginning, it thinks it is a PostScript file, which is not a very good detection. It also tries all kind of non-rejected formats. It tries these formats in a loop and just takes the first that just happened. So we run HLatex, and so with auto-injection of hyperref, and so a lot of things were automatically done. What actually was supported was DVI-PISPS to PDF run, so plain LaTeX or TeX. The PDF LaTeX route was also added, and for plain TeX we only had actual plain TeX and then DVI-PISPS. LaTeX runs did run until stable, until to a max number with references missing or something. Plain TeX was only runs once, and we had put together multiple PDF pages with multiple PDFs with PDF pages. So that was the system. Also, there was no way for the submitter to actually indicate which file should be compiled, which is a huge problem because many people just upload also templates of their journal and other documents or the same document in 3 different variants, and Autotext compiled all of them and put them all together. So there were a lot. So what were the problems? Well, first, no LuaTeX, no XeTeX support. BibTeX, Biber, MakeIndex was not supported. Your people were needed to upload the BBL file. And that was always painful because it was always out of date, references missing, wrong versions, real problem. MakeIndex was not supported at all. Then PDF pages, if you have tried to merge PDFs with PDF pages and have links in there, they are just broken afterwards, which is also not very nice. I mentioned already detection of the main document was often incorrect. Then, if you have seen an arXiv paper, maybe on the left, we normally have some watermark. Also, that was very fragile. It didn't detect, so it sometimes printed over stuff. Well, many things. Probably many more things I haven't seen, well, I didn't mention. So, yeah, we also had, okay, we did run, or till very recently run on Cornell IT servers, and so every time a new server was installed, the whole TeX system had to be installed. It just happened once in the beginning when I was at arXiv that we realized that all the PDFs had no fonts embedded suddenly, because, not the PDF, the PostScript files had no fonts embedded. No, the PDF also had no fonts embedded, which was very strange because if the font was not available, you probably have seen these nice wobbly letters. Yeah, so because it was incorrectly set up, there are not, I have to say at the current moment, there are not very many tech experts at arXiv, and so the setup was sometimes broken. So what we did over the, let's say, last 1.5 years, so the one big part is like everything is going to the cloud. We have to leave Cornell Tech, since we are also now independent, and in addition to replace the amusing Perl code with a bit more standardized Python. And one of the big things was getting rid of the auto part. We really want submitters to decide which main file do you want to compile, which PDF LaTeX or LaTeX or whatever, and maybe also we'll see later which TeX-Live version. Because, I mean, this is a decision they have to do. We shouldn't do this automatically. And then also add a lot of new features. So to give you an idea how, I mean, has anyone submitted a paper to arXiv in recent times? Yes, 3, 4, not a lot. So what happens, I just give you a quick flow. You first come to a page where you have to do these preliminaries, license agreement and confirmation of authorship, and you are the author. Then you upload the files. You can upload whatever, more or less whatever you want. And then we run a Preflight. This is what I talk afterwards about. This is a quick parser of TeX files, not only TeX files. This gives a response, so it auto-fills in, like if it finds only one new top-level file, then it's automatically selected. It selects the engine. I will talk about this. Then the user selects the TeX Live version. At the moment, we support 23 and 25. Selects the main input file. I mean, the Preflight does it for you, but it might be incorrect. The auto selects the compiler, which can be TeX, PDF LaTeX, or XTeX nowadays. And then there's a test compilation that goes through the dockerized version I will talk about later. If there is success, the author should check the PDF. Unfortunately, many people don't do this. Then there's metadata input and it's finished. So that's the run. We have also afterwards, offline, it's called the publish cycle, when we assign archive IDs. We have another TeX compilation running that recompiles and puts also the watermark that will be simplified in the future. So that looks more like, so what's the information we get from the Preflight? The first thing is like select the compiler here. It's automatically selecting PDF LaTeX. So there's also a change. Before the default was LaTeX with TVIPS. We switched now the default to PDF LaTeX and 2025 TeX Live. You can select the others. You can select the top level TeX file. You can add multiple. If you have multiple top level files, you can have 3, 4 files that compile. And the Preflight also does some quality checks. Like for example, here we have some of these very nice people who submit images of, I don't know, 10 million, 100 megapixel or something. So 10,000 by 10,000s, and then they imagine just putting this in an A4 page. That is about a resolution, I don't want to know, like 3,000 pixels per inch. I don't know why, especially since often it's... Why?
Some people do experiments with satellite imaging.
Yes, sure, but if you put it in the PDF, it doesn't make sense. I agree that those data is very important, should put it in the ancillary files that people can look at the high resolution image, completely agreed. But often these are just graphics stitched together. Yeah. Anyway, so that looks like this. We also show the file list of what has been uploaded. This is actually a real submission. And we give some notes on the auto detection, like what should be kept. And well, here the BIP file is here and the BBL file is here. So in this case, the BBL file will be used. User can then delete files if they're not used. So what is Preflight? What is doing this? So this is a really simple parser. So our aim was, well, we cannot run TeX because it might time out, it might error, it doesn't really help. We want to help the submitter to select the correct thing, because we have seen it, and we still see it too many times, that the submitter just upload strange things, select incorrect things. So we at least want to nudge them in the correct way. So what it does at the moment is read all those files, text, style, LTX, PDF, TeX, PDF, TDEF files. It checks all the image files are there. The checking of the image file supports the graphic path if you have it in the LaTeX code. It generates from the TeX files. It checks for all inclusions. I show you which inclusion comments are used, like include graphics or input. It generates a forest of what is there, and then it determines what are the top level files. It determines the engine, the top level file, the document class that doesn't need to be in the top level file, right? You can have a TeX file that starts with whatever and then includes a file that contains the document class. So even this, we have these cases, so we have to deal with this. That works. It determines the engine by, well, just checking which packages are loaded, what kind of comments are there. It determines the language, whether it's plain TeX or LaTeX, by just trapping for typical examples. So these are the current set of include comments that are supported. I went through thanks to several people from the LaTeX team, they gave me a long list, and I went through a lot of packages. It's definitely not complete, but it's a sufficient, well, sufficient. It's a considerable selection of what you can do, including loading CSV files and data files and all this kind of stuff. So bibliographies are handled also correctly. So if the BBL is there, we also check the BBL version. Now, BBL version, this is only happening when you run Biber, because then it generates an XML file that has a version number. And if you run it with a different BibLaTeX version, you get an error. So we check for this. We check the presence of the necessary bib files that are included, which, yeah, the BBL format I mentioned. And yeah, whether we can regenerate the BBL or we cannot regenerate. Might be that some bib file is missing, then we cannot regenerate it. But that's fine. People still continue to upload BBL files, and some people just upload the bib files. Both is fine. By the way, the same works with the index files. It supports also the index files. You can name them very strangely. You can have arbitrary names for this intent index file. All of this is supported. Other features that Preflight does, so it does a file presence check. So it pipes all files that, not completely all files, I don't go into details, but it actually looks them up with libcapacere. The first try was with the command line, but it was far too slow. So with help of people, there's a TeX script that you just send the files to the TeX script with the necessary extensions, and the TeX script returns which files it had found. The stuff that is returned from Preflight then normally excludes the files from the techmfdist directory, right? We assume this is there, but if you load some other files that should be in your upload, and it's not there, then Preflight will tell you, hey, did you upload this file? It is missing or it is used. We do image checks, as I mentioned above. It does check for 34 megapixel. This is, I think I computed this by A4 page at 600 or 1200 dpi. That should be enough for everything. It also checks for PNG files which can be embedded quickly into PDF LaTeX. So their PNG files are internally zlib compressed, and if they have an alpha channel, if they have some properties, then the embedding into the PDF by PDF LaTeX needs to recompress, also uncompress and recompress the file, and that takes a lot of time and can time out the LaTeX compilation because we have time limits. We have more checks like embedded JavaScript code, so we don't want JavaScript, sorry Media9. And then I don't know why, but maybe it's the fingers are used to type something else that they want, because there are PDF files like every other day that are actually PNG files. I don't know why, but yeah, it happens. Interestingly, LaTeX accepts this without, it doesn't care for whether it's a PDF or PNG, it just works. Our authors are unhappy when I tell them this is a PNG, not a PDF, but anyway. Okay, so what is returned from Preflight? I mean, there is a formal specification in Bacchus normal form, but I mean, it basically gives a status which is either, okay, I succeeded to parse this or error. Then it gives a list of TeX files that it has found. We go into details what is in this array here. Detect the top level files, because there can be multiple. Image files, ancillary files. So this is mostly for arXiv, because people can upload ancillary files exactly for this case where you have high resolution images that accompany the article. And maybe used files, I actually forgot what it was. The Preflight couldn't determine what it is, but it might be used. So the TeX file entries just check whether it contains document class, the file name, whether it's LaTeX or TeX, which other files are included. These are image files or data files. And then there's an array of issues. So we collect issues like a missing file that is included, or yeah, there are a lot of issues that are connected here. They detect the top-level files, again, the file name, hyperref found. That's more or less history, but it came back from times. Then how to process it. I define a compiler by the engine, the language, the output format, and the post-processor. We don't support it by now, but in future I'm thinking also about supporting UpTech. And you could also, in principle, support XLaTeX with DVI output and then DVI PDFMX. There are people who want this. It's all laid out to support this in principle. At arXiv, we only support a much smaller part at the moment. And again, issues for the top-level file here. The image file, well, straightforward file name, file bytes, I mean the size, width and height of the image, how many megapixels, and this detection whether it can be copied quickly into the PDF. This image is returned. So Preflight status, it is now in production since over a year. It runs on every single submission that people send. Yes, well, not completely. Well, we have HTML submissions also, it doesn't run on the HTML. It is stable, we haven't had any single crash in the last year. It just returns errors, might be, but in most of the cases it just works. Of course, I mean, it's a simple parser, right? It's super easy to break, not to break, but just to do things that it doesn't support, right? The easiest thing is like defining your own include graphics macro. Like define a macro that use include graphics, because we don't do macro expansion by now. I'm working on this. So there's also no, as I said, no macro, no cat goes, no frisk, nothing else. Also support for, there's a lot of those freezers, you know, when you have listings or SVG or something, that pre-compute stuff and then only include them. Some of them we support already. The biggest one that is open for me is the SVG package support I'm working on. So it might not be perfect, but for our audience, actually it works very nice, right? The papers we get at arXiv normally, in by far most of the cases, don't have like super complicated macro programming on the LaTeX side. It's mostly like small definitions. We have the occasional people who include graphics into a macro by themselves, but I run it over like tens of thousands of submissions, and it worked by far over 90%. So it is usable, it is not perfect, far from. I'm more than happy if people contribute or improve it. Yeah, so that's Preflight, as I said. The next one is dockerized compilation. This is, again, very simple. It's a web service. We had a far more complicated web service that actually uses also GCP buckets and all this kind of stuff and was written to serve the arXiv pages. We dropped this completely. It's not necessary. We just have this text to PDF service now. You just upload the TUG with the files and preferably a 00 readme JSON. I don't go into much details here. It returns, again, a TUG which contains at least one JSON file. The JSON file might be just tell you, okay, that didn't work, or it tells you all the runs that it made, like LaTeX, BibTeX, DVI-PS if it was necessary, and also includes then the generated files. It works. We have, so this is, the service is much more complicated than it looks on the surface, because, as I said, we have to compile old versions too. So we put all of these TTech and TechLive that run still Autotech behind the same API, and we allow one of the front, the most recent, to be a proxy and then just call back to other compilation services. So we have, for every of the text system you saw there before, we have one web service running. It's a cloud function, cloud run, that hangs there and sleeps basically until someone wants to compile something in this version. So this is this auto-dispatch to the respective TechLive years. That is probably only interesting for us. because the API endpoints are very simple, just convert. You can send, if you want to run Preflight, you just send Preflight v2. Don't ask why, it's a long history. API can be simplified, actually I'm doing this. You can send various watermark parameters if you want to stamp a watermark on top of this, archive ID or timestamps. So the submission you send normally should contain a so-called 00readme.json, which defines what is the top-level file, which should be compiled with which compiler. So that is the decisions the user made. You can just put it in yourself. You can call with auto-detect and it runs Preflight and automatically runs the front. You can run the stamp by yourself, and then there's just some TechLife whatever endpoints about what TechLife is used there. So new features we have, based on these two things, a few new features we have rolled out over the last year. First of things, bubble wrapping over calls. Max helped a lot here. I'm greatly indebted to him. So all the calls are, so to say, in a stronger than a change root. I don't go into the Linux details here. We added BIP to BBL conversion that was not there, including auto detection of which BIP-LaTeX driver they are using. Still the presence of submitted BBL wins. Same for MacIndex compilation, it is there. We added XLaTeX compiler, which got super big pickup. Very simple reason, because people often use EPS and PDF. And PDF LaTeX, as we run it, we don't have shell escape, so we cannot run the EPS to PDF. So lots of these nowadays use XLaTeX, if this is. We added, I mean, this is just a gadget. I think nobody actually uses PDF tech. I mean, plain tech with PDF output, anyway. The PNG size check I mentioned already. I improved the watermarking, first with PyMu PDF, but then due to the invasive license of PyMu PDF, we had to eviscerate this again and now use PDF Oxide and Pike PDF for that. Unfortunately, well, yeah. The concatenation we changed also. As I mentioned before, the PDF pages just destroys the internal link. Also, I first used GhostScript, but that also had problems. Nowadays I use a funny tool, PDF CPU. I wasn't aware of that, but it's the only tool I know that consistently concatenates multiple PDF files and preserves links outside, inside the document, everything. And it's written by a Viennese developer, surprisingly. It's not me. Sort, I mean, you don't, that's not important. Sort is a standard for submitting stuff. We also pass this out. There is a lot of wishlist items, I have to say. So LuaTeX support, I still need a bit more testing. And font cache setup, again, Max already suggested a lot of things, it's just my time too low. Then endless improvements to Preflight. The cache support I mentioned already, especially the SVG part. A big problem is that the LaTeX core had considerable changes in TechLife 2024 onward, that a lot of publisher packages are breaking. So I'm not really sure how to go forward here, especially since we want to introduce 2026. But we probably have to keep 23 for those packages. Yeah, I'm not very happy about this, but nothing to do about. I'm also working on better QA handling. So we have quality criteria. So we don't want line numbers. We don't want LaTeX documents that only include images as pages because, well, we want the source code, not images, right? This is already a work in progress and will probably deploy it. Okay, so it's available, it's open source, you can use it, it is under this, there is a lot of stuff there. It's very much work in progress. I do fix a lot of things now and then. There is no releases, no packages by now. That will come when it has settled at some point. There's insufficient documentation, I have to say. Just ask me, I will. No, I mean, so the formats and all the documents are actually formally specified. I just have to transfer them from the arXiv pages, which are not accessible to the public, to the repository. The 00 README file is also documented there. I skip this here. So this is available here. And yeah, thanks to all the developers and of tools that go into TeX Live. And Island of Tech team who builds our base containers for TeX Live. They do a lot of work. Okay, that's it. Thanks a lot.
We have any questions? I see Carl. How about you?
I have one. I need this one. I just have one non-technical question. We can talk about the technical ones later. At the beginning, you said arXiv was very open. Do you see that changing after July 1st?
No. None of the things, well, I cannot speak for the future, right? None of the things at the moment are changing. We still publish our financial report, just came out for the last year. The committees at the councils all are out. We have no intention to change the policy about so source code uploads. So the change to NPO, the aim is that there is, besides the color and the ink, there should be no other change to users, right? That's the aim, right?
John Bowman. I was a little worried about the pre-flight inspection. What happens if that fails? Because I'm like one of those people who I like to avoid duplicate labels and file names. I use the same, so I have a macro for my include graphics, for example. Will that fail? And I have
if it fails, the user can always select everything manually by themselves.
Oh, great.
So it is not a forced on the user. It's a suggestion to the user. It's not perfect, I know it, so I would never say, okay, this is what you have to do. User can always override what is there. People do this and they fail because they think they have to upload and they want to compile with LaTeX, so they select LaTeX and then they have PDF and PNG files and wonder why it doesn't compile.
Okay, that's wonderful.
Yeah, so no problem on this side.
Thank you. This is Tactile. For the older version of TeX-Lib, there are some known security vulnerability. Did you address this kind of problem in your system?
Well, no. We use the well, it's okay. I speak loud enough, and I have this stuff here. So yes, I'm well aware. So for example, we don't support well, LuaTeX we anyway don't support by now, which is the biggest. The other, we don't support shell escape completely, and then every run is in a change route that is even strengthens by Linux namespace separation without network access, without access to the process table. So I mean, it's not perfect, but it's the best we can do. I will not patch TTech2 or I don't know, TeX-Live 1009 or something. Yes, I know this is a problem. That's one of the big reasons that all this, the security, putting them as compartmentalized as possible, we did over the last year.
Boris.
Well, not me, but a user from the chat suggested looking into MTX run for combining files because it also preserves links. The TeX-Live MTX run.
Yes, that needs like LuaTeX and 50,000 other things. And thank you for the suggestion.
We're a little bit over here. I think we need to break for lunch, but let's thank Norbert again.
Yeah, thanks everyone.
For those who don't know who I am, I'm the relatively new elected president of DANTE since 1.5 years, so just that you know who I am. And I've got the honor to be session chair of this afternoon session. And first, we hear something else from Vít Starý Novotný from the Masaryk University. He taught us earlier this day about Expltools tools and Expltools, whatever. And now he's doing something about the Markdown package, where he's also the author, one of the authors, and he tells something about Abbreviations in the Markdown package. Have fun. You need this one too? Yes.
I think so, otherwise I won't be heard in the room.
Yeah, there you go.
Okay.
Pinch the top, yeah. It's the down alphabet. Yeah, it's backwards.
So, good afternoon. I'm Vít, and in my talk I'm going to discuss some recent developments in the Markdown package for TeX, which are intended to make it easier for both editors and authors to mark up abbreviations. So let's just allow a little moment for the slides to show up. So in traditional typography, abbreviations are not just shortened words, but typographic objects that call for special treatment. Here's an excerpt from Robert Brinkhorst, who recommends typesetting most abbreviations using spaced small caps, which is a convention I'll use throughout the slides. And in TeX, marking up abbreviations is often tedious and fragile, since once an abbreviation is introduced, authors must revisit earlier text and also remember to apply the same markup throughout the remainder of the document. And this talk presents new support for abbreviations in the Markdown package for TeX, which shifts abbreviation handling from a procedural to a more declarative model. So let's first talk about some of the requirements in the design. So the primary user interface is going to be a new option called acronyms, which is a comma list that lists all the different abbreviations that you want the Markdown package to know about. And that's going to implicitly produce acronym nodes for all occurrences of HTML and other abbreviations that turn up in your Markdown text. There's a number of questions to be answered, which will help to refine the requirements. So first, what should count as an occurrence? If HTML is listed, should we also match inside XHTML, HTML5, HTML-based, and so on? Should we automatically match plurals, such as APIs, if there is an API, and so on. So that's one question. Another question is if you list both HTML and HTML5 in your acronyms option, which one should we produce an acronym node for? Should it be the HTML or the HTML5? Also, Unicode normalization, should we try to match differently normalized variants of an abbreviation or not? A big question is efficiency, because the acronyms, they don't have any special markup. They can appear anywhere in the text. So how are we going to do this efficiently, do this checking efficiently at almost every point? And also a question of boundaries, which is closely related to the first question, where do these, can the abbreviations span multiple words? In addition to, where can they start? Can they also be not just a single word, but multiple words? And we can answer those questions. So as for the first question, we decided that we should refuse the temptation to guess and have the editors list all the abbreviations explicitly, including the plurals, which is a bit more work, but it also reduces any false positive matches where we actually don't want an abbreviation. So, for example, you would need to explicitly list XHTML, HTML5, APIs, and so on. As for the longest matching, we would always match the longest possible abbreviation using a dynamically built PEG parser that encodes a prefix tree of all abbreviations and matches the longest possible abbreviation by default. So if you specified both HTML and HTML5, then we would produce an abbreviation node for the HTML5 one, which is what you would expect. As for the Unicode normalization, we just use what is already inside the Markdown package, and we use the pre-existing options for Unicode normalization to normalize both the text and the abbreviations provided in the acronyms option, so that we can match, so that they are both in the same format, and we can match them even if they are not in the same encoding initially. And as for the boundaries, we still require that an abbreviation must start and finish at word boundaries, but they can span multiple words. And that's also why we need a PEG parser for this, because if an abbreviation could be just a single word, then it would be easy, right? We would just check the following word and just look into a hash table. But here, we don't know how many words the abbreviation could possibly span, so we need something smarter. So those are the requirements and also the design for the feature. So let's have a look at some actual examples of the user interface. So this is how the editors could predefine some abbreviations. So first you load the Markdown package and you specify the acronyms that you want, and then you just type your text and the abbreviations are implicitly detected and can be formatted. By default, they produce this spaced small caps format. Alternatively, you could also import the acronyms from the glossaries package, which we support by default. So you just use the glossaries package, and the output is what you would expect. And if you're the author, you can also use explicit markup to mark up your acronyms, and they will get the same treatment as the ones which are predefined by the editors. What's also interesting is that you can mark up the abbreviations just once, and they will be correctly formatted throughout. This requires multiple compilations. So during the first compilation, this one would be formatted like an acronym. These two wouldn't, because this entire mark inline is done as a single invocation. So these two JSONs are they are not special, but during the evaluation of this, JSON is actually added to the acronyms option. So the next one is already formatted correctly, in the first run, because when this mark inline is encountered, the option has already been updated. And in addition to updating the acronyms option, it also updates the .aux file. So in the next run, we know that JSON is an abbreviation from the beginning. So in the second run, we get this output as expected. So this is nice for the authors because unlike in the example which you saw on the second slide, where you introduce an acronym and then or an abbreviation, and then you have to go through all the occurrences, it's sufficient if you mark one of the occurrences and the rest will follow automatically. So this reduces the potential for human error. So we've seen the design and the user interface. So now let's look at how it's implemented under the hood. So for example, the option acronyms and these 4 acronyms produces the following peg parser. In addition to this parser, you also need the actual abbreviation to be surrounded by punctuation, white space, or text boundaries, and it is applied to all plain text, including places where we don't usually allow markup, such as image titles. In Markdown, image titles are just plain text, no markup allowed, but for this option, we will also produce abbreviation nodes within the image title. And the implementation was kindly co-authored by my student, Andrej Genčur. As for importing from the glossaries package, we add each acronym text, such as HTML, to the option acronyms. We use an inverted index, which maps the text of the acronym back to the glossaries package label. And then whenever the acronym is encountered in the text, it's rendered as the short form of the acronym using the label, which is retrieved from the inverted index. So this happens by default when you just load the Markdown package, which preloads the default definitions for LaTeX. But if you disable this, there are good reasons to disable the default definitions. You have some template and you don't want changes to the default definitions affect your template, then you can cherry pick just this functionality using a built-in snippet called Witico/glossaries. And here is an overview of what I already discussed earlier, where the use of explicit markup makes 2 changes. First, it updates the option acronyms, and it also adds the acronyms to the .aux file, so that in subsequent compilation runs, even abbreviations that precede the first markup occurrence are correctly formatted. So in conclusion, abbreviations require special treatment, but marking them up consistently can be difficult. And the purpose of this talk was to introduce new support for abbreviations in the Markdown package for TeX. Authors and editors can work independently to define a shared set of abbreviations, and the 2 approaches which I have shown, or the 3 approaches actually, the one using the option acronyms, the one using the glossaries package, the one using the explicit markup, all of these can be combined in the document so that the editor and author, they don't need to talk to each other, but they can collaborate to the desired end result, where all the abbreviations are correctly formatted throughout the document without anyone stepping on anyone else's toes. So that's it. Thank you for your attention.
Thanks, Vít, for the talk. Are there any questions in the room? Yes, Max. Okay.
Hi, yes, it's Max Chungoff. So for one of the slides, you gave the example of APIs, like the plural. So, and then you also, I thought that you said that you don't match the middle of the word. So that APIs example, how would that work?
Yeah, so you would need to type acronyms equals API, comma, APIs.
Okay.
Like the package is, it's language agnostic, so we don't want to have special rules for plurals in English.
And then if you want the S to not be small cap, oh, sorry. And then if you want that S to be not, oh, sorry, yeah. If you want the S to not be in small caps, but just like the A, P, and the I to be in small caps, how would that work?
Well, the Markdown package is like a Lego. So this just produces an acronym node, which you can redefine. By default, it just does the simple thing. It uses spaced small caps for the whole for the whole word, but you can add your own logic into how it's rendered.
Thank you.
So further questions? Carl?
I can talk loud enough without that. Vid, a couple more slides in, you showed the output with the heading glossaries. A couple more, one more maybe. There we go. The HTML and the YAML underneath acronyms do not look like they've been applied, acronized. Is that intentional?
Yeah, that's just how the glossaries package does it by default. So I expect the author to configure the glossaries package. I think that's outside the scope of what the Markdown package does.
Okay, there was one more question.
Hi, I'm Marcel Krüger. Can you go to the slide with the LPAC parser? I was just wondering for the first one, why the L is duplicated for both cases. So you have HTML and then HTML5 and the L is separately present for both. Is there some reason for that or just some implementation detail?
Yeah, I mean, it's the parser is automatically generated, right? And the idea is to match HTML5 before you try to match HTML. So you're trying to match the longest possible acronym first. So that's why it's repeated. The PEG parser first tries HTML5, and when it fails, it backtracks and tries HTML.
I was just wondering why the L is not outside of the parentheses.
Right after 5?
Surrounded by parentheses, but you could factor out the L and have 5 plus nothing.
After 5.
You mean this one? Yeah. So it's either L followed by 5, and if this fails, it retries this. So you think it could be parenthesized differently?
No, L could be after the right paren. No.
It couldn't, right? Because it tries the different lines. Each line is for a different acronym, so it needs to be parenthesized.
Why is there an extra L at the end? Just give me a second.
It's an or.
Who wants?
Why is there an extra L at the end? Because you have HTML5L.
Yeah, well, there is a star, which is concatenation, and there is a plus, which is alternation. So it's either HTML5, or if the match fails, it tries HTML. That's why.
So, okay, Paul has another question.
So, can you go back again to the glossaries slide?
To which slide?
To the glossary slide.
Okay.
Or any of these. So it looked to me like in the code, maybe it's even clearer on the previous one, whichever, but in the code it looked like HTML and YAML are being acronized in the code that you're showing, not in the output.
Yeah, yeah.
But ordinarily, you would not want to put acronyms in code listings. So the question is, can the package not apply the acronym in certain cases?
Oh, it doesn't. Yeah. In my slides, I formatted all the occurrences of the acronyms. The package doesn't do that. So I said that it formats the acronyms even in places where markup is usually not allowed, such as image titles, but within verbatim text. No, there's no acronyms. No worries.
Are there further questions? Yes, Eric. Long way to go to Eric. So here you go.
I was wondering if there could also be another, like not acronym, but maybe macros, for example, for LaTeX or context or those kind of stuff. Because every Markdown file I recognize by LaTeX not being typesetted properly.
Yeah, that's a great question, and I was wondering whether I should add another slide for this. So thanks for reading my mind. Yes, I mean it was easy to do in the Markdown package for TeX because it's like a closed ecosystem, so it's easy to add. But not just a macro. You could use in LuaTeX. You could even intercept the individual lines of the input, and even have the part where the markup is implicit, like in the Markdown package. You could have some issues if the abbreviation is split across several lines, because LPEG, as far as I'm aware, LPEG, which is the library used for parsing, requires the input to be a string. It can't work in an incremental fashion. I know that there is some LPEG implementation in pure Lua, so I suppose you could adapt that to have some incremental LPEG parsing library, and in which case you could track the abbreviations from across multiple lines and correctly format even that. So yeah, I think there is definitely space for LaTeX, LuaTeX package like this, which would automatically format acronyms that would be completely independent on the Markdown package for TeX.
So there's a further question. Ulrike?
What do you do if you want one occurrence not to be marked up as an acronym?
Yeah, there is in the default definitions for LaTeX. There is currently no provision for this, but you can redefine what all the class name attributes mean. So you could have a special one called no acronym, which would locally redefine the acronym node renderer to do nothing or something like that. It's easy to add, but by default we don't have any special provisions for that.
Okay, are there any further questions? Well, Boris has none, I already asked them. So thanks a lot for your interesting talk. So the next guy we have the honor to listen is a former musician, now doing something with coding. Just to repeat his words from yesterday. Erik Nijenhuis, I hope this is correct. You got your mic there. You said something about executable document templates for safe and reproducible document sharing. Have fun.
Nijenhuis is a real hard last name to pronounce, I guess, for foreigners or not Dutch people. Thank you. This is an extension to my previous talk about, I will extend on it eventually on the accessibility matters, and also an extension of my previous presentation in India. There I also covered the executable document templates, for example. Let's skip this one. So the context this day will be about government correspondence, or cases, I guess. Contracts disclosure files with sensitive data. So, for example, in the Netherlands, we can request a freedom of information request, and then the government has to get into all those files, blacken out all those sensitive information, and it's all done by hand, poor people. And it's error prone, that's one thing. It's a lot of work. Yeah, and you actually don't want to make any mistake in these cases. So I would like to give them an illustration on how to do it better, or at least, yeah, but it's not Word. That's for the Dutch people a big issue. So it's about structure, data, and context. So normally I would just leave out the values and instead show placeholders. That's where I created Lua placeholders for. But for their case, that's not good enough. It has to match the exact document, only the sensitive information blacked out, and preferably not the real information behind it once you inspect the PDF. I didn't do it like Ulrike has shown on Thursday, but I will eventually do the sanity check, I guess. So I will first demonstrate the recipe-only approach. So this isn't good enough for them, but then again, but it should be, I would see this as the most safe option. So for example, this is the plain document. So Mr. Smith, that's who is it appointed to, so that's sensitive, and there's a lot of other sensitive information. So this is normally what you'll find if you're opening a Word document. No placeholders or no variables or nothing. So that's the second stage. We have to apply those. So we'll check all variables, we placeholder them, and we have data, a payload, and then the actual, or the filled in example looks like this box here. So if we leave the values out, we see the placeholder names. I think this is a way better approach because it's actually saying what it is, like applicant name, national ID, and applicant address, which gives a meaning, and then you also may have an idea why it's rejected in the first place. Yeah, but it's the wrong shape, so placeholder values aren't the same as an actual value, and the values can actually differ. So we have to do another approach. So I will be black barring, and firstly I will do it a bit naively. Just the LaTeX way, I guess, but you'll notice maybe that it's not the same as it was. Maybe go back. No, this one. So you see the last value, it has a line break in it. And here it isn't, and we'll get spaced out a bit. So this isn't a nice solution, so we'll have to do something better. And in those cases, I will go to Lua. And in specific, the post line break filter. And you can see the full implementation in the preprint on page 25 till 27. So this was my first attempt in Lua, and if you're looking very closely, you'll see a hairline over here. I didn't see it in the preprint, so printing actually works. But yeah, mostly you'll get a digital version of it, so you'll see those hairlines, and they're not seamless. It would be nice if we could get this together and as well as this. I mean, that's what I mostly see. So we have to attach it to each other. Oh no, no. We're first covering my typical mistake. First do some research. What packages are already there? Yeah, and it's exactly this stage where I thought, oops, again, I forgot to do my research. So let's cover those existing packages first before submitting another package to C10 or something. So we have the sensor package, and Lua sensor package, which is a Lua-based one, and src redact, which isn't the same, but it showed up when I searched redact on C10. So let's take a look at those packages. So this one, yeah, the downside of this one is it can't hyphenate. So it won't get that exact spacing I was talking about earlier. So yeah, I would not use this one as a robust version. And then the Lua sensor does actually some weird stuff with the spacing. It randomizes. And if we zoom in, you'll see here some notches. I'm not comfortable with that as well. And like I said, this package doesn't provide a bar at all. So let's skip that one. So back to the bar, 2 flaws to fix. So I talked about the hairline, and I want to have it in a seamless bar. And this is my second approach, and I left out the code, I guess. Yep. And you'll see it will get broken down on the line break. It will include the spacing of the hyphenate, and I filter out the disks, which were the reason why the hairline was there at some cases. And yeah, okay. So those that's it. The spaces are tricky. So it can be shorter than a space or larger than a space. So you'll have to calculate that. I don't know if the code in the preprint is fully robust for every situation. I've tried some, and if you want the minimal working example I have created for it, well, please ask me. I'm happy to provide you the full source code. So what do we gain? Anonymization, which is structural, not cosmetic. We can reuse it. So I chose to grab on Lua placeholders, which is handy for variables. And you can typically split up namespaces like client data, which you want to redact, for example, so you can just fully redact that data in one time. And it's reproducible. Same recipe plus payload, same PDF. And yeah, the typographic quality is, well, as I would like to see it. But there's also another use case. So, for example, in Dutch law, there are some rules like a sentence which endangers the security of the state. So this isn't a variable. This is in prose, right? Like in the text somewhere. So you'll have to also be able to do that. But since we already created the engine in Lua, we can just simply make an environment for that. So you will see those attributes in the preprint, and now we can wrap it around in the environment so the sentence is blackened out as well, and also has the same spacing, etc. So what I said earlier, like the placeholders, are actually giving some information. And now I didn't write something to include the legal ground, but it should. Like you want to address why you are redacting something, so you can choose which grounds you actually want to redact for a specific case. And there's I just had texts, but maybe dates, numbers, tables, etc., or figures I forgot to include. Those are as well may have to be redacted at some point. And the build flag gates, well, I did create a public implementation which showcases how you can extend LuaLatex options. So what I would think would be a good approach is having build flags on the command line, which you can give legal grounds, and then you don't even have to touch the sources and get a variable redacted version of the document. But maybe you also have ideas. So thank you for listening.
Thank you for talking. So are there any questions for Erik? I hope so, because we're really ahead of time. So.
Yeah, but we also have a very important presentation afterwards.
Yes, maybe. You have a question? For sure, Carl.
So my question is, how did you come to write this? I'm guessing the Dutch government did not ask you, but maybe they did.
No, the Dutch government certainly didn't ask me. The Dutch government is very heavy Microsoft based, so they only use Word, also at universities. But however, I wanted to showcase some advanced Lua features. So this includes the line break filter, which is very useful.
So there's another question, Marcel.
Not really a question, more of a remark regarding, you mentioned that you have do some calculation to determine the real size of glue if it potentially stretches or shrinks. There is actually a built-in LuaTeX function where you can call the internal calculation for that. You just have to pass in the outer box and it gives you exactly the right size.
Thanks.
Are there further questions? Yes. So here you go.
I realize that the government doesn't have to make sense, but if it's important to preserve the original formatting, it seems that that leaks a lot of information. For instance, if there's a name that's either your name or my name, your name is longer, someone can tell which it is. And all the more so when it's preserving things like breaks between words and sentences. So I think that this kind of thing that they're requiring comes from trying to simulate going over with the black marker. But is there any move towards trying to do something that would be more secure?
Yeah, I would simply use the Lua placeholder default stuff, like showing the placeholders instead of giving away its length.
I mean, getting them to accept that.
Getting, well, they're pretty ignorant, so I won't, I won't succeed in any way in that. Yeah.
They use Microsoft, so I don't think they have an issue with that. Okay, further questions? Yes, Jasper.
I'm really sorry, this is really pedantic and probably not me is the best person to say this. But there is a really cool Lua function called register TeX command that lets you interface with Lua and call Lua functions from TeX macros. Max wrote it, and I love using it for interfacing. It might, I noticed you were using direct Lua with big commands in it, and I just thought I would mention that. Sorry.
Thanks. Further questions? Boris, do you have questions for us? None questions so far. So thanks a lot, Erik.
Thank you, sir.
Okay, our next speaker is John Lienhardt from the MIT. He's a mechanical engineer at the Water and Mechanical Engineering Department at the MIT. Especially, he's known for the MIT thesis, and he tells us something how he modernized this. So this is yours.
Okay, this is what we're.
And this one.
A lot of IT.
Yes. Okay.
Too many hands. All right, thank you all. I've been a tech user for about 40 years, been a TUG member for about 30 years, but this is the first time that I'm presenting at a TUG conference. It's honestly kind of a pleasure to be here and to meet people who I've interacted with virtually, in some cases for a long time. I'd say Frank's book was a bit of a Bible to me when I was learning the details of LaTeX. Ulrika has been incredibly generous in answering my questions over the years. And I've used software written by many of you, including Nelson, Carl, and others. So thank you all for that. You've kind of built the scaffold here. I have to say, though, that I therefore approach this conference a bit like a graduate student giving his first talk to a technical community. So forgive me if I mess things up a little bit. Just to plug, I understand that my wife and my father are watching. Hey, folks. So let me see if I can operate the comm. There we go. So background on this. First of all, just a bit about MIT's thesis requirements. MIT has very loose requirements. There's a strict formatting requirement for the title page and what must be in it. There is a strict formatting requirement on the abstract page. There's an optional page where you can list committee members, but it's not required. The only other requirement is to number the pages starting at page 1. So to that extent, it feels kind of loose. MIT gets about 1,500 theses each year, the majority of which are in LaTeX. We're a science and tech institution primarily, and so many of our theses are math heavy and really need those features. The other interesting thing about that environment is that many of the people writing theses are first-time LaTeX users. Maybe a more experienced student has done 5 to 10 journal or conference papers in LaTeX. On the other hand, many of them are exquisite coders and absolutely fearless about diving into new syntax and sending me comments on the class file and so forth. So it's a diverse group. Now, we've had a thesis template in LaTeX since about 1987. It's written in LaTeX 209. That template was patched by a later graduate student for LaTeX 2E. And after 1999, there were really only trivial modifications made, just little details. And so it's been passed around informally. MIT doesn't really manage it. By 2020, the cover page no longer met the formal requirements of the MIT libraries. It was still set up for inked signatures, which we no longer used. And there are also execution problems. I never paid any attention to any of this because, of course, I'd already written my thesis. And I only ever got the print documents submitted to me. But in the early 2020s, the libraries went to PDF-only submission. Started during COVID as a temporary measure, and then they said, this is great, let's dump the paper. And that's when I started to get concerned. I knew from reading Tugboat that there were significant changes to LaTeX in progress that were required by legal mandates for accessibility, and that this was going to mean that a PDF-only format as they had it would really not work in the long run. And so I started looking at this. As you can see, I decided that the old code had to go completely, and I rewrote the entire template. So what were the goals? First of all, I wanted to make it easy for beginners to get an attractive result. I didn't want them to have to be fiddling around with the details of the title page and so forth. I wanted to use LaTeX as it exists now and as it will exist next year. So I've been trying to track the evolution of LaTeX as I'm writing. At present, I only am backward compatible to 2022. We don't really need backward compatibility for the following reasons. The students mostly have a short residence time at the Institute. The ones who have installed their own version of TechLive can be presumed to be able to update their own version of TechLive. And so I haven't thought that the backward compatibility is a big issue, and I've never encountered a problem. In fact, I've rolled backward compatibility forward. Originally it was 2020, now it's 2022. Next year it will probably be 2023. So I really want the students to use current code. The code is tagged, and it is compliant with UA2 and A4F with embedded CSS. I'm going to stop short of claiming that it is accessible, because there still needs to be work on things like reading order and navigation, and perhaps some of the finer details of WCAG that are almost, that really require human judgment rather than machine translation. I wanted to support a variety of fonts. I'll show you an example of how that's done. I won't get into the design options, but it's possible to load a file that controls the design outside the class. And after hearing Frank speak about templates, I realized that that file ought to contain templates so that the students can really do what they need to do there. Finally, tagging is supported only for Lua. I'm not trying to support it in PDF tech. The reasons for that are pretty straightforward. Lua is necessary for automatic generation of MathML, and our theses are math heavy, so that kind of ends that discussion. What I'm going to talk about today, I will talk about the required content. I will talk about the user macros briefly, how the students are putting in information. I'll give some examples of how XBEL3 code is used. That's mainly for the benefit of folks who don't already use XBEL3. I'm not claiming to teach anything dramatic there. I will talk a bit about what I've done with tagging and some of the challenges I encountered trying to think about how to put tags in a document. And then finally, I'll show some samples. So here's a typical title page. Title of the thesis, our author, Silas, getting a degree from the Department of Physics, a Bachelor of Science. He is retaining the copyright to himself. And of course, there's a required waiver to give MIT rights. And then in the block where the ink signatures used to go, we have Silas's name, his supervisor's name, the name of the person who formally approves the thesis for the department. The second column, Silas has proceeded to get a degree in a master's degree in computational nuclear materials. That is actually a real degree at MIT. It's issued by the Department of Nuclear Science and Engineering and the Center for Computation. So 2 departments, 1 degree, and that means that when we get to the bottom here, we've got 2 departmental acceptors approving it. When we come to this third one, Silas has acquired a co-author, Luisa Hernandez. Luisa has several previous degrees, which are stacked under here, including one from the Vulcan Science Academy and one from the Ferengi School of Management. And so down here we have 2 author signatures. And in this case, they're using a Creative Commons license, making it more readily available. So each of these combinations has to go in a certain way, and if it doesn't, if it isn't correct, the libraries won't take the thesis. And that's where it becomes a little trickier. What I'm showing on this page in highlight are the things that the student or the user must provide. So obviously a title, they need to provide their name, the department they're in. If they have previous degrees, these are options. I've allowed for up to 4 previous degrees. I don't think any students have that many. And then for the departments, there's the name of the degree and the department giving it. If 2 departments give it, they can leave the degree name out here and put in the second department. The month and year that are allowed, if they're using a Creative Commons license, tell us what it is. And then, of course, we have the date they submitted the thesis, supervisor's name, title, optional department, acceptor, the person who approves the thesis, name, title, and department required. What you'll see about this page is that it's typographically very simple. It's centered blocks of text, vertical skips, and then down at the bottom, presentation table. And I've highlighted that. I want to call attention to it. This table is tagged as an ARIA table, which in principle will solve the accessibility problem that goes with using a table for layout. I think some additional work is needed there around reading order, but this is what's here now and validates. Now, here's a little Expel3. I won't go into huge detail. The author command has the name, department, the optional degrees. If they're not given, these are just empty. This is fed into an Expel3 command, and the Expel3 command increments a counter, first author, second author, third author, and then it loads each of those 6 potential fields into its own sequence. So a sequence is essentially a numbered group of items, and so we're storing the successive author names in an author name sequence, departments, previous degrees if they exist, which then allows us to develop all of the content on the front page just by counting through integers, and it's all built with essentially integer loops. One thing that the page does, because you know how many authors there are, you can, for example, put in and or a comma as needed, plurals as needed, the author's release or the author releases. All of that is generated automatically. This content is typically processed by make title. So there's a fairly involved make title in this document. And you have to do it that way because you don't know until the end how many authors have been input, how many degrees, and so forth. Looking at this presentation table I mentioned, again, we've got some integers we're tracking. It's a tabular. We'll go through an integer loop up to the number of authors involved. And then we will put in, say, authored by, author name, author department, and the date, some space. If there's another author, we'll list that, and so on and so forth. And this will then terminate later. Class options for fonts. So the students have various choices. I set up 10 different font sets that they can call. 2 of them that I'm showing here are Heroes with Sticks for the math. Over here it's Libertinus for text and math. And you can get different appearances as suits you. Since there's no spec, it's really up to the student what they prefer to do. The font sets that are available work with, in some cases, only PDF tech. In other cases, only a Unicode, essentially. Only Luau, I should say. And a few of them work with both if they're available, both as OpenType and as a PDF font. How are these done? Well, when we get to the document class, we have an option for a font set. They can pick, say, Libertinus. This will call an external file outside the class for that font. I'm not going to go into the details of it. It is essentially routine font setup with some switches to determine what engine is running. This file can be edited by the student. If they want to change Nabla to a different font, they can do it there. And if they want to use some font that I haven't set up, they can do that there as well. So it's really exporting all of that to the user. Options are handled by LaTeX new key value method. For example, this Libertinus would be stored in a token list and used later to determine what to load. If you want to load the line no package for editing, it'll set a Boolean for that, and that will be processed later. if you're loading the design file, there's a code that's executed that actually runs some tests and loads things a little more carefully. So it's very much similar to what you can do with other option packages, but it's native to LaTeX, and we don't need to load a separate file for options. Regex. Regex is fun. It allows you to hunt for characters and take them in and out of strings. So how am I using it here? This is a supervisor. This particular supervisor has many titles in several different areas. And so each of those titles might need to appear below the supervisor's name. And since it's a presentation table, tabular, I would load this using a double backslash ampersand. And so on the title page, Secunda will appear with her several titles listed and a comma saying that she is one of the thesis supervisors. And it will work great. Now, the challenge comes when you get to something like this optional thesis committee members page. And the problem here is that Secunda's titles are now formatted. And what happens? Well, what happens is you have a problem formatting these active characters. So where do we go? We can look at the, well, let me back up a step. When I say they're formatted, you saw italic. They are actually emphasized. And the reason for this is that emphasis carries semantic meaning in PDF. Italic is just a font switch. And so it has no particular meaning and doesn't carry over. But by using emphasis, I ensure that when I go, say, into HTML, I will get an emphasized or typically italicized set of characters. The problem is that you can't put these in emphasis. So what I'm doing is I'm defining a regex. I put the double backslash into a constant token. And then with the regex definition, I say hunt for a double backslash followed by any number of spaces and an ampersand. And so we'll look for that. Similarly, we can look for a slash ampersand as well. When the list of titles of Secunda are put in, they're stored in a temporary token list. Regex splits everything when it finds the double backslash ampersand, puts it into a sequence. We also go through that sequence, and every place a student has used a backslash ampersand, we replace it with the word and, because this is a formal document. Departments and titles use the word and not ampersands. So that's strict. And then finally, we'll go through the sequence with a sequence map, emphasize each element, and put these things out separated by a double backslash ampersand. So we've essentially torn the title list apart and restored it with the information we want. Here's another bit of XBEL 3. It's nice to have commas between successive footnotes. The very traditional way to do this might be to redefine the footnote command to have a future let at the end. The future let will then look at whatever follows the footnote command and store it in next token. The command is other f note will test next token. If it is a footnote, it will insert a superscript comma. And so we'll get the commas we want. Going over to XBEL 3, instead, we can use peak meaning. And so we can look at the following token. If its meaning is footnote, this command inserts into the input stream superscripted comma. And so this will come through directly. And then we can use the nice hook mechanism, which I really like, to attach the note comma to the end of the footnote command. And so it will test the next token. There's a little problem. You're inside the footnote command. The next token is the end group. And so you need an expand after to get that to carry through. What's nice here, though, is that we're not redefining footnote. And as I've looked at tagging code, I am more and more sensitive to not redefining LaTeX commands. All right, so making a tagged PDF. Everybody has mentioned, whoops, what did I do?
I hope you have nothing.
There we go. Everyone has mentioned, oops, there we are, the need to use document metadata with all the appropriate switches in it to get everything properly tagged. Of course, you want to avoid incompatible packages. That's been mentioned already. Some elements, particularly on our title page, require manual tagging. So I will show examples of how things can be manually tagged as we go along. And then a couple of things that, no, what am I doing? Am I totally not using the mic? Do I need this? I've been holding it behind my back, which makes me wonder. Yeah. So a couple of things that I encountered as a class author in thinking about how to get tags in. First of all, I needed to actually stop and understand the elements of PDF, the levels of PDF structural elements. You have groupings, like a div that wraps a whole bunch of stuff. You have block level items like a paragraph or a part. And inside a block level, you might have an inline level like a span. The significance of this is that if you issue a span, for example, in vertical mode, then your parent-child hierarchy of tags will blow up. At least it does for me. And so I found a couple of cases where I needed to affirmatively make sure I got down to block level, for example, by using leave v mode. The other thing that was important is semantic meaning versus typography. We do so many things typographically to convey meaning. That's what typography does. And on the other hand, not all of the typographic things we do mean anything semantically. I mentioned, for example, switching the font with text IT versus emphasizing it and putting an emphasis tag or structural element onto the group. Another one that I've encountered is the use of new line. So new line doesn't start a new paragraph, it just moves you down. And it's a really convenient way to stack all of a professor's many titles below their name. The problem is that when you convert this to HTML, those many titles are just a run-on string without any separation. And that needs to be looked at as well. So these kinds of things came up quite a bit, and it wasn't really until I was writing the paper for this conference that I thought carefully about the way I had actually had to learn about these details. So let me talk about the title page tagging. Now we're getting into manual tags. The whole thing is tagged as a section. I'm only showing the top bit, but I've made the entire title page its own section. We of course need to tag the title. And since I'm using my own set of macros here, I need to actually affirmatively say this is the title and do appropriate things with it as well to put the title into the metadata, which is also done automatically. Here I wanted to tag the title strong so that it would appear as bold by default if it were translated over to HTML, and strong as an inline tag. So I found it necessary to leave v mode at this point before tagging the content strong. The author block as a whole, I've put that into a div, an author-defined group. The whole block of degree information, I've put that into a div. Obviously, it's arbitrary where I draw these things. And I picked ones that made sense to me, but I think as the use cases become more clear, the groupings of these manual tags will evolve. And so I regard that as a bit provisional. I mentioned user-defined tags. This has proven to be important for what I've been doing. So tag PDF lets you set a new tag. I created a div called author, a div called degree. I put a div around the entire signature block of the title page. And I also, for example, wrap the nomenclature list in a div. And I'll give you some idea why as I get toward the CSS code. One of the things that became very important, and this was, I think, when David Carlisle started running the package through his parsers, you need to have a namespace defined for these user tags. They're not a part of the PDF 1.7 or PDF 2.0 namespace. And so I've created a namespace here called MIT Thesis that holds these things and allows the software to know what to do with them. So let's see what's happening with these tags as we get into the presentation table. I've mentioned presentation several times. So the tabular that holds the author's supervisor acceptor is specifically tagged as a presentation table. What that does is it gives it the ARIA role of presentation. And that tells the PDF readers not to announce that this is a table and start spewing out a lot of information that's not so relevant for a block that holds text. Inside this, I'm again counting through another integer loop, incrementing a step counter, and on the author by phrase, I'm putting a span around it. This phrase actually sits inside a table cell, a TD if you like, but I'm tagging that specifically because I want to manipulate this later. And so when I get to putting CSS into the file, I'll look for a div of type signature block. I wrap that around the signature block. I will look then for a table that has the ARIA role presentation. I'll go into a row, a cell, and I'll look for a span. There's only one of those defined. There's one for author, one for supervisor, one for acceptor. But for each of those things, I will then put a margin on the top because I want some spacing when this is rendered. Here's what it looks like. So I take this to ngpdf.com in HTML with the CSS and those tags. The title page renders as shown. And you can see my half M of space separating each of these name blocks here. That's what that was about. You can see I've got a title that's rendering in bold type. There's a facility in the tag PDF for loading CSS. And so you can come in, make sure that you're using tagging, make sure the file exists, and then you can add to the list the file that holds any CSS that you want to apply when the thing is translated to HTML. Give messages if it doesn't exist. Continuing, incompatible packages have been, as those of you who've worked with tagging know, are a headache. And for me, the caption package has been a bête noire because not simply for this package, I have another class that I work on where the caption requirements are strict, not user selectable. And so I've wanted to control this. Over time, Ulrika has kindly provided me with several patches for caption that have helped me make things work. More recently, it's developed that we have a caption socket, a socket on the caption label, and also that we can add a hook to the caption command itself. So here what I've done, just for example, is to define a socket plug. I'm saying text color will be red, the argument will be in bold, and there'll be a quad after it, which gives me the label you see here. And then I'm hooking before the entire caption, saying I want a sans serif font. And so that hits both the caption and the label. If you wanted the label in a different font, you could vary a font selection in this command and it would override the earlier hook. So those things are doable. Of course, Frank, I know you're working on templates for this, and this is all. New version at some point. I'm going to have to do it over, but for this year, it's working, and this is what I'm doing. Oh, that's great. And I'll change it later. So. It's nice to see things happening this way. Yeah. Appreciate it. Thank you. Yeah, and so below the caption, so some of you, when you've set tables, you find the table caption sitting right on that top rule. I don't like that, and I usually manually put in a space. It turns out, though, that there is a hook after caption that you can use, and so you could go in and say, test, is the caption type table? Okay, if it is table, let's put in a skip. Then we get some space automatically. We don't have to go through and fix all the tables. So hooks give us all kinds of neat tricks that we can do. They are a great way to go. So I'll come to some HTML samples next. I want a drink of water. So you can see this. This is an AMS align environment. This is rendered as it comes directly out of LaTeX. And I've got an equation here that was relevant to my graduate studies, so of course it's kind of sacred to me, and I see it quite a bit. What you'll notice is I've got my vectors in an upright bold font. And you might typically do that just by calling mathbf. If you do that and then you render this into HTML, that bold will just sort of disappear. It's a font selection. On the other hand, if you use, we're in Luau, so if you use symbf up, that's calling a specific Unicode glyph, and that will carry over. So in this case, I've selected these Unicode glyphs globally. And Unicode Math gives us a class option that will always call math boldface from the symbol font rather than the text font. And so this is one thing that I only discovered when I was doing conversions. This Ulrika was a space that we discussed the other day. It's here because of a bug in someone else's code, not Ulrika's. And not mine. So I mentioned wrapping a div around the nomenclature list. On screen, nomenclature tends to be narrow, and if you do it single column, it's very long. It's kind of typographically horrible. So when converting, again, to HTML, because I wrapped the nomenclature list with an identifiable div, I can say, look for a div of this class, find an unnumbered list, and then make it 2-column and put in a column gap. If you prefer 3-column, you could do that. If you don't like this at all, you could simply delete that CSS. Users can edit. This is the reference list for that particular sample document. This one is generated with BibLaTeX and some CSS. It's pretty much as it comes out of the box here for the active tech material. For CSS, I had to take some steps to ensure that the labels stayed on the same line as the label body. To get the indents, there was some work to make all that come out the way you see it. But the references themselves are exactly as rendered. And by and large, I think they came out pretty well. You have italic where you'd expect it. You have hyperlinks as you would expect them. The only thing I was disappointed by was in this paper, I had put in a little add-on to BibLaTeX to make the volume number bold, and that didn't carry through. And when I tried the most obvious fix, everything exploded and I had a mess. And I haven't taken the time to really drill into that one yet. But overall, it looks okay. Tables, so this is a representative table, again, as it's coming through the translator. In this case, as others have mentioned, you do need to tell the tagging what's the header row. And so here the header row is row 1. That will generally ensure that your header row has bold text. I found it didn't ensure that you had bold math. And since this is a math table, I had to add some CSS to say, in a table header row, all math children will have this font weight and a normal style. I'm declaring it important so it overrides anything else that wants to manipulate those particular fields. Boldface captions in the labels. So there's automatically a div called caption, and inside that there's automatically a span called label. So I can go in and say I want bold weight on the caption label. I can also go after that span with some more CSS, and I can add half a quad of space to separate them. So we have a lot of tools once we get there if things are properly tagged. One note, I noticed the tables are wrapped in a table body. They don't have a specifically called out table head. I don't know if that's important, but it's one of the things you find in CSS tables. And then here, I mentioned the issue of line breaks, and I'll show you what brought it to my attention. This is PDF, This is Silas and Louisa again. And this is the HTML rendering. Oh, and they've got another author, Thurston Howell III. That's an obscure joke that only some of you might get. Anybody here seen Gilligan's Island? All right, a few people. TV comedy from the 1960s in the US. And Canada. Sorry, my apologies. Yeah, and elsewhere. Yes. So this is what happens to the previous degrees. Here we're using new line, and I'm setting Louisa's 2 degrees on a separate line, on separate lines. Typographically, perfectly sensible. Over here, because the new line doesn't mean anything, these wind up in a single line group. And if I hadn't put the period at the end of these degrees, this would all just smear together. And you would have to guess whether the master's degree was in 2018 or what. It would be quite confusing. So that's an area where there's probably more to be done. This is how I've left it for the moment. And then these are just a couple of more examples. This is to show you, first of all, we can get math to render in headings as we would like. Equations come out neatly. We have working hyperlinks for all the references, so everything clicks through as it should. This large matrix, I apologize, Carl, I think I stole this, or a version of this, from your huge document on math. I think also your version had h.4 up here rather than dots in each cell. There's an open issue on h.4 and tagging, so I took it out and just put these in instead. But otherwise it renders quite nicely, and large matrices. These are our superscripted, our commas separated by, our footnotes separated by commas. The commas are there, they're dropped to the baseline. Again, I'll say that's a bug in somebody else's code, not Ulrika's or mine. So, and I think those are the slides I prepared. I didn't expect to have time. There are a few extras. Is there patience? All right.
Go ahead.
I will skip past the closing slide. I mentioned metadata. And so it's possible, and I try as hard as I can to automate the metadata, because telling a student you need to put all this metadata in is going to be a problematic process. They want to write their thesis. They don't want to fiddle with these other things. So title, author, copyright author, all of those things are constructed by the class and put into a hyper setup within the class. One thing that's also done is to add the XMP copyright property. There is a facility for this in the current code. In fact, there is also a brand new user level macro that will do this, which I just discovered a couple weeks ago. But this is built in and can be done. When you come down here, then in the class, I'm declaring the copyright in a long string. The copyright author, if it was Silas, Louisa, and Thurston, would be built to include a comma after Silas, Oxford comma, and after Louisa. And then at the end, the last person, Thurston, there's a period here. You have a little problem if this person is, say, Thurston Jr., and the junior has a period after it, because you can wind up with a double period. So there's code to strip double periods as well. And then there's a very long statement here, also constructed to allow for one or more than one author, which announces MIT's rights in the document. So this stuff is all built in. I've also been patching a bit. I like to make the front matter and the back matter look differently. I should have mentioned, this document is built on the report class. So that's the basic framework. The report class does not have front matter and back matter built in. And so it's necessary for me to make some modifications. I'm patching list of figures to tell it to essentially to go look for, where is it, L at front matter as its style rather than L at chapter. and I'm patching list of tables the same way. And I also have a patch for the references to get the back matter. And the reason I'm doing this is I want them italicized, displayed a little differently than the main body. All this is currently being done with patch command. Again, I know there are templates in progress that will eventually tackle LHAT chapter and other things, so this code will evolve as time goes by. I mentioned the Libertinus font input file. It's nothing special here, but I ask if it's PDF tech. I'll go through loading the Libertinus new TX math packages with some setups and the bold math package, the BM package. If it's not, I'm going to assume that we're running Lua. We have a Unicode-aware engine, and then I'll load Unicode math with various font settings, Libertinus math and Libertinus serif. In this case, I'm changing the Nabla as well with one from Latin Modern. And the other font set files are similar animals doing similar things, but that's how that's handled. Let me see. Okay, I did something.
So I don't know that.
What's that?
It's on our end, the thing did something weird. So
Oh, there we go. Went back. I'm not going to go through details here. The images on the front page are coffins. And I use coffins and join them with poles in order to get the separation that I wanted at that point. It turns out that coffins are boxes, and that box tagging depends on where the box is used. And I thank Ulrika again for helping me figure this out. But these coffins, when they are set up, you need to save the structure, stash it. And then when you get down to actually typesetting these coffins, you need to issue each of their tags there. And so there's a delayed process to get that tagging to stick. So, with that, I'm going to quit. This is MIT's mascot, Tim the Beaver. I assume he's a Canadian beaver. And this talk was put together using LTX Talk, Xcolor, and Xcoffins with the Heroes and Incancelata fonts. So it's a talk with a colophon.
So thanks a lot, John. Interesting part for me. It's the first talk I ever saw where someone mentioned hooks and sockets and not from Frank. Great stuff. So, are there any questions? I guess. Not yet? Not, Boris? Frank, do you have something? Want to add something? No? Okay, but Carl has something.
So, John, I'm curious. Most of the examples you showed us were HTML, and you obviously put a lot of time into making that HTML look right. Why?
Well, first of all, I had to look at the HTML in order to check that things were being tagged and laid out properly. And I don't like HTML that looks like Netscape 4.0. Secondly, I suspect, in fact, I expect that the ability to convert tagged PDF directly to HTML will attract its own attention separately from accessibility. And in particular, if I'm going to, say, go to people at MIT and say, look what you get from tagging, it's better if it looks nice when they look at it. But I want to be clear. There's more work to be done on accessibility. I'm sure that I've got UA2 here, and I'm pretty confident in the HTML I get. But for accessibility, we still need to look at issues related to reading, issues related to navigation, and for that, what I really need is a standard platform for testing. If I were a Windows user, I think I'd go to NVDA or JAWS. I'm a Mac user, and that's the problem. So
any further questions? Oh, a signal command from Frank.
I don't know. Very much appreciated. I love actually seeing things, not me talking about sockets and hooks. But that's precisely why we did those kind of things, because I think they proved to be relevant going forward and helpful. The small comment that I wanted to make was about your last sentence about you think you produce UA2.
Yes.
And we think we produce UA2. That's not true.
Okay.
UA2 actually says you have to do the manual checks as well. That's part of UA2. So we are claiming by writing it into the file that this is UA2. The claim actually only gets as far as the automatic checks that we can do. So effectively, the standard UA2 has all these kind of extra requirements, if you like, that we can only tell the people to actually do. So yeah, we are all producing UA2 to the extent that automation can do it.
Yes.
Just as a...
That's a very good point, and it relates also
now
to...
she's going to correct me.
No,
Before you start, Ulrike,
No.
on the UA2, the WCAG as well, requirements like alt text must be comprehensible cannot be checked by machine. So please.
No, but I think as you got quite good HTML, I would be quite confident also about the accessibility of the PDF. So that's a good test to do. Checking the reading order with NVDA is good, fine, but HTML conversion already gives you a very good indication that you got the main structures okay and the reading order okay. That's a good, very good to do this.
Thank you very much.
So thanks, Ulrike. Are there any further questions, remarks, something like that? No? So thank you again, John, for a very interesting talk. And I think there is cookies outside. Yes, and we see you again at So, hello back. And the last session of this afternoon. Now, the next talk is not long, as I saw. It's of a girl named Adelheid Bonnetsmüller. Oh, that's me, I guess. 10 minutes, yes, got it. Okay, there are some slides. Yes. Okay, what is this all about? This was the question. Where is this one? Oops, down. I wanted myself as I saw this point on the program. So, yeah. Okay, so it says Dante EV presentation. So I do something about Dante, I thought, when it's on the program. Okay, first guess, talk about Dante. So maybe there are some in this room that don't know what Dante is. Perhaps it's no problem. Dante is the German-speaking TeX Users Group Association. So that means we're located in Germany, Austria, and Switzerland. Around about 1,700 members. Twice a year we have some conferences with some books with something like the Tugboat, the Technic Comedian. Yes, and why Dante? The first thing, as an anecdote, I heard when I started with Dante in the early 2000s, they told me, because I asked why Dante. Dante was not even a German guy. And they told me, oh yeah, that was a bit of a problem. We wanted to name us Gutenberg, because Gutenberg for sure is a German guy. In the middle of Germany, he was born in Mainz. That's really quite in the middle. Yeah, but Dante was founded on 14th of April 1989. And there was other guys just around the border, just across the border from France. And they said, okay, we found ourselves in September 88, and we call ourselves Gutenberg. So, okay, this name was not free anymore. Okay, then we said, okay, let's do Dante, because Deutschsprachige, die Anwendervereinigung, AN, Anwendervereinigung, T, TeX, EV is just an abbreviation. So, and bad for the Italian guys, because for them only GUID was left. So this is what Dante is. As I told you earlier, I was elected as a president 1.5 years ago. I have fun doing this job. And yes, I deal with TeX in different ways since the beginning of the 2000s when I started my studies. So, okay, but I'm not here for doing something about Dante and give you a report of our yearly things we do and whatever. This is what I do when there is Dante meeting and not TUG meeting. Okay, there has been something different. Good. Now I came to the reason why I'm really here and talk to you. There's one person in the room that is a very important constant in the whole TeX universe. He's for a long time, since 2003, he became a president of a user group. He's in the board of this user group till now. That means he started being a president when I even started going to Dante meetings. That's cool. He does something that's called TeX Live. He's much involved in that. You cannot imagine TeX Live without him. But he always was involved very much in this Web2C TeX stuff and this KPIT CEO. And yes, he's a really great networker. I think everyone knows about him. Everyone knows him all around the world, in the TeX world. And at least he's one of the persons, besides our other honor member, Barbara, he's one of the persons doing the Tugboat together. So, Dante promoted in our spring meeting in Lanao this year, Carl Berry as an honor member of Dante. So I would just ask Carl to come to me. So I've brought a little thing with me, and I'm hopeful. I'm glad the glass didn't break. I hope I don't break it now, so take it. Yes. Carl, it's an honor to me. It's an honor to Dante. Many greetings from all the board, from the complete board of Dante, from Lucia and who else? You know them all. Congrats.
Thank you. Thank you, Adelheid, obviously, and everybody at Dante. It's a great honor. I never expected it. We did obviously discuss this beforehand, but it was a big surprise. And as Dante has been it's the biggest user group. They're bigger than TUG at this point and have been for years. And they do so much to support tech and TUG. They helped contribute to this conference and all conferences for going back many years. So I appreciate them very much, and I'm very honored to now be an honorary member of the country where I was born.
I didn't know about that. That's great. Thanks. So perhaps it would be okay, Carl, if we could make a photo afterwards, because Lucia is asking me. I should bring a photo for our technical comedian. Okay, so we're a little bit ahead of time. It took me only 3 minutes to say what I have to say. So, but nevertheless, the next speaker is Mitchell Gerard, I don't know exactly. He's doing something stuff with literate programming. And this is quite interesting because I try to do my homework. That means I have to prepare the guys who are talking here, and so that I could say what they are doing. And I found a talk from you of the TUG meeting in Prague, 2024, and you talked about Holon programming. I never heard about that, and I wondered, okay, how much stupid? I never heard anything about it. So I listened to this talk, and he said, I don't know either what it is. So that's great, and now you're talking a lot more of literate programming. I'm really looking forward to this. Yes, hey, Masha.
Hello, everyone. Actually, I'm going to start a timer so I kind of know where I am. Okay, hello everyone. Today I'll be talking about some history of the web system of literate programming, which is what TeX and Metafont are written in. And we'll also look at other possible directions for literate programming systems. This is part of a project that will very soon be published as a book from the TeX users group entitled Pre-Literate Programming, Writings and Interviews. This book is an anthology of precursors to Donald Knuth's literate programming, as well as interviews with Knuth and his students at that time, and a few other bits. So this proof copy arrived at Carl's door on Wednesday, so it's hot off the press. And I'll send it around for show and tell. But first, Erik emphasized yesterday that he is not a bookworm, so please just skip Erik when it's passed around. The cover here depicts Hugo, a medieval monk, scratching out a scribal mistake in his structured program. I just want to note that the book is not yet on sale. That will be in a few weeks, give or take. But here's the link right here for that eventuality.
Nothing there yet.
Yes, it is TK, yeah, to come. This anthology project began with tracking down Pierre Arnauld de Marneffe's 1973 report on a system he called Holon Programming, which is shown here, the title page to Holon Programming, a Survey, which Donald Knuth cites as a primary influence on web. This report was privately circulated and for a time seemed to be lost to history, but was recently made publicly available. And we'll talk more about de Marneffe's vision soon, but there are many more influences on web than just de Marneffe. So this is the first page of Knuth's 1981 handwritten draft of web. which was initially called DOC, short for documentation. And web, along with much of Knuth's other works, was composed on this extra long legal paper from a Canadian manufacturer. And in the interview in the anthology, Knuth gives the specifications of this paper. He says, quote, "It's 8.5 inches wide and 14 inches high, thus legal size, with ruled lines about 5 millimeters apart. I still use it to write The Art of Computer Programming, but my supply is running out. I've asked my sister, who is a Canadian citizen, to see if she can get me some more, but she hasn't been successful," end quote. So if anyone in the audience or listening out there knows where in Canada this paper is made, please let Knuth know. If we zoom in on this draft, well, Knuth's handwriting isn't the easiest to read, but if you squint, you can maybe make out the sentence, quote, "It is impossible to list all the related work that has influenced the design of DOC, but the key contributions should be mentioned here." And so here is a list of authors and interviewees included in the anthology, many of the names coming from Knuth's initial list. Some of these names are well known to many, like Edsger Dijkstra and Nicholas Wirth, and others are deep cuts whose pieces are being published for the first time. But of course, the list of influences goes on, and I couldn't include everything. So permit me to just mention here 2 fossils from the days before web. Here on the left is a page from the 1914 natural language algorithm from Leonardo Torres Quevedo, a Spanish engineer and inventor. And this algorithm describes a chess-playing automaton, a very early one. And on the right is Peter Nauer's 1962 ALGOL compiler documentation. Nauer's documentation and his command of English was just amazing. But even though we couldn't include everything, the anthology includes pointers to many of these old influences. So in editing this book, I looked at different embryonic specimens whose parts can now be discerned in web. So tracking literate programming in its early stages led to the question, what other forms could it take? But before discussing possible varieties of literate programming, I should distinguish literate systems from non-literate ones. I'm calling a literate system one that allows the programmer to mix source code snippets with natural language, together with the ability to permute pieces of the program text. So this is a very, very rough taxonomy, but it allows us to distinguish something like Jupyter Notebooks on the left here as non-literate, as they don't allow code reordering. You need to execute one cell after the other, and org babel mode in GNU Emacs as literate, because in org babel you can use a no-web-like markup that lets you permute your code. Both are quite similar to each other, as both allow prose and figures to go alongside the source code, but there is something essential in this ability to permute code. Knuth calls systems that don't allow reordering quote-unquote zeroth order literate programming. So there are many literate systems out there because a literate programmer's favorite thing is to make their own framework. And so here are just some of them. There are hundreds on GitHub if you look. But even with the previous broad definition of literate programming, they all look and function pretty much exactly like web, okay? So as Taco Hookwater writes, there are some differences between all these literate programming systems, but overall, they're all something like 95 to 99% compatible with each other. But spiders weave all sorts of webs. There are sheet webs, triangular webs, tangle webs, orb webs, funnel webs, and more. So today we're going to try to dream up some new webs of our own. One interviewee for the anthology was David Fuchs, to whom TeX the program was dedicated. And so here is Fuchs, depicted in medieval monk clothing. Specifically, the wardrobe is from 12th century French manuscript. And in the interview, Fuchs talks about running TeX 78 on 36-bit machines and deciphering poorly printed Pascal user reports. But at one point, he digresses into the future and speculates on other possible directions web could take. He says, I always wondered if one could design a literate programming language from the ground up that would be directly compilable with no Tangle equivalent needed. And just to clarify, Tangle is a program that takes a web program and converts it to pure Pascal, which hopefully compiles successfully to give you an executable. And so this two-step process is very much a part of web, both with Tangle and its companion program Weave. And then Fuchs goes on to list some desirable features of this system. There would be no textual substitution macros, which he notes were just put into web as a way to get around Pascal's limitations. The compiler would decide if the modules or sections would be inlined directly or would be wrapped in a procedure. And this future language wouldn't feel like two languages bolted together by a third, like Pascal and TeX bolted together with web, but would be one integrated language with only one set of rules to remember. But wait, what's past is prologue, and Dimarnev dreamt up this kind of integrated system before web even came onto the scene. So again, this is the title page we saw earlier to the Whole-on Programming Survey from 1973. And this work came out of the structured programming debates. And Belgian computer scientist Pierre-Arnaud Dimarnev wondered if a language could be built so that structured design was a property woven into the language itself, rather than a discipline imposed by the programmer's own diligence. So he designed the Whole-on Programming language, with one of the goals being that the programmer can present the program in mostly natural language, in the same order that the design decisions were made. So the kind of design Dimarnev imagined was a pure top-down design, where each task could be represented by a hierarchic tree, and with tasks broken into subtasks. And here he was very much influenced by Dijkstra's ideas of semantic layering that Pavneet mentioned this morning. So for example, if your task is to get a drink of water, this can be decomposed into smaller tasks. Find the water, find a cup, fill the cup, and drink it up. So the basic unit would be the whole-on, borrowed from Arthur Kessler's word for something both whole in itself and part of something larger. So that quote is actually Kessler's, not Dimarnev's, that's my bad. The idea was that a program should be decomposed into small self-contained sections, each written largely in natural language, and each nested inside other whole-ons, forming a hierarchy of holes within holes. So some of the early structured programming proposals expected the programmer to translate a structured design written in kind of a pseudo-language into a program written in a conventional language, and they expected that translation to be done by hand. But Dimarnev noted that this translation step is non-trivial and quite error-prone, and he thought that the programmer should be using the same language for the design and the implementation of a program. Namely, just like Fuchs, he wanted to make the design language compiled directly to an executable. So here is part of a whole-on program from the 1973 report. And the program originates from Dijkstra's Notes on Structured Programming, one of his later revisions to it. And the details aren't important here, but you'll see it's mostly natural language description with the algol-like code given here between the # delimiters. And then the compiler would transform the whole-on program into what is eventually an executable. So on the right, Dimarnev shows a legal algol program here, which for Dimarnev was only supposed to be an intermediate form in his compilation process, but which Knuth saw and envisioned as the actual output of Tangle. And we can see the similarity between Dimarnev's whole-on the left and an equivalent module written in Knuth's web here on the right. But the two aren't entirely the same, and there are actually quite a few differences in Dimarnev's report. One is that with holons, scope mostly follows from a holon's place in the holon tree, so that a variable declared in an outer holon is visible to everything nested inside it, but it is not visible to the sibling nodes, so these nodes at the bottom that share a parent. And this is not the case with web. That's not how the scoping works. Another difference is that there were sophisticated compilation techniques planned where holons would become either inline code or they would be wrapped in procedures based on a number of factors, very similar to Fuchs's sketch for a new literate programming language. But unfortunately, Demarneff's planned language was never implemented. It was a huge project that he had envisioned with all kinds of extra bells and whistles, and this was for a very quick dissertation done in France, which is a very short time that they allot for dissertations to be completed. And so holons would remain a part of a language existing only on paper. That is, until a recent literate programming tool resuscitated the term, which brings us to our next character, Graham Nelson. Nelson is a mathematician, he's a poet and a writer, and he created InWeb, which is a semi-literate, fully literate, semi-recent literate programming tool. I don't have a picture of Nelson, so I couldn't turn him into a monk, but using InWeb, he wrote one of the largest literate programs to date, which is an interactive fiction programming language called Inform. It's now Inform 7. And he's also written a number of very influential interactive fiction works, including Curses from 1993. And this is a slight aside, but one of the original interactive fiction games was Colossal Cave Adventure, which many of you have probably heard of. And it's a beloved program of Nelson, Knuth, and many others. And Knuth rewrote, actually a rewrite of Adventure as a literate program, which you can find in his Selected Papers on Fun and Games book, or on his webpage. There's an updated version of that. So I just have to recommend this paper by Dennis Jertz. That's a great historical dive into the original Adventure code and the spelunking that went along with it. So check that out. But let's get back to Nelson. The anthology project brought me into contact with him, and I was amazed to see this in the latest update to his tool. InWeb includes holons. So here, a holon is just like a section or chunk in one of the typical web systems, except that a holon is a language construct with semantic meaning, rather than being an unchecked macro substitution. And so this came out of Nelson using CWeb for a number of years and running into a number of problems. And so one of the problems had to do with, this is an email exchange from Nelson, one of the problems had to do with polluted variable namespaces and being unclear on what exactly each variable's scope is. And I really like his droll CWeb module title here. There are many advantages to treating holon as language construct, including, so it depends on what your base programming language is here. There are ways to say, I'm using Python, I'm using a C-like language, etc. I'm not going to go into the details. But some of the advantages include correctly inserting block delimiters, such as braces or begin end pairs, avoiding the dangling else ambiguity, and preserving indentation for whitespace sensitive languages like Python or Haskell. And I just want to note that this last item had been previously solved by other literate programmers, such as Norman Ramsey in his NoWeb, and he just passes the code chunks straight through to solve this problem. So check out Graham Nelson's InWeb, which even has a notation mechanism that allows you to transform a well-commented non-literate program into a typeset booklet that you can read by the fire. Or, as Frank mentioned yesterday, you can even take some of the pre-LaTeX 209 class files that are brilliant if you want to be an archaeologist. So those two can be beautifully transformed. But Graham Nelson was not the first person to run into problems from the fact that web modules are simple macro replacements. So let's go back to a 1981 Tugboat article where Knuth details some of his first experiences with web. In this article, he lists 8 bugs he found while writing glue.web, or as Dijkstra would say, that he inserted into glue.web. And so one of these bugs is due to accidentally forgetting Pascal's begin and end delimiters. And then later in his 1987 Stanford class on mathematical writing, he mentions quote-unquote appalling bugs that will occur if you, the web programmer, do not adopt the habit of putting your begins and ends inside the called modules and not putting them in the calling module. In his interview in the anthology, he cites monthly bugs in his C-Web programs due to clobbering a value from a variable used in another module. Well, each of these problems Knuth mentions are exactly the kinds of errors that Graham-Nelson's hold-ons prevent. So why then did Knuth not place language features into Web and C-Web that would solve these scoping issues? Or why not create a more unified language? Then only one set of rules needs to be remembered, rather than the rules to Web, Pascal, and TeX, as well as the interactions between each of these three. Well, one answer comes from Knuth's 1974 letter to de Marneffe, and a snippet is shown here. Knuth encourages de Marneffe to implement the hold-on programming language before saying, I myself must get on with the writing of volume 4 of my series, so I have little energy to devote to the development of languages. Of course, he would go on to develop some more languages, but at that time, Knuth had already designed a few languages, and he knew that implementing de Marneffe's entire ideas would be extremely time-intensive. So Knuth knows that the interaction rules in web can bite you, but it's a system that has worked well enough for decades. He says, I use C-Web knowing that it was a quick and dirty implementation, but it still does almost everything that I want, exactly as I want. And again, from his mathematical writing course, he says, quote, now of course, if I had a programming system, if web were not being patched on top of Pascal, and I was really using a programming environment, my programming environment would do this for me. It would make sure that I wouldn't make such errors. And here he's referring to the begin and end delimiters, end quote. So of course, Knuth made web as an experiment used to implement TeX and Metafont, and more importantly, to present them to other humans to read. He says that web is just a demonstration of what could be done. So for anyone implementing a new literate system, go ahead and try adding some of de Marneffe's ideas. So add parameters to the chunks or sections, and then give them Algol W's 4 different possibilities of parameter passing. Or you can take from Peter Nauer and add an explicit cluster construct scoped around a stated invariant, and then checked at cluster boundaries. So go crazy, experiment, and spin some new webs. Many people have been indispensable throughout this project, so thanks so much to everyone on this list, and to Sophia, who shouldn't be missing from this list, and especially thanks to Andreas Scherer for reading the quote-unquote final proof. Andreas was very meticulous in his notes. So Andreas is the maintainer of C-Web right now, and Andreas even pointed out an incorrect math equation from a classic Nicholas Wirth paper that had slipped by the communications of the ACM editors. And he had many other notes like this, so thank you, Andreas. But of course, the biggest thanks go to Barbara and Carl, who proposed the project. They read everything, and sometimes read everything multiple times. They patiently edited my insistence on a back of book index, and they gave the best suggestions and support. It's been a ton of fun collaborating with you two, so let's make some more books. Thank you.
Thanks, Mitchell, for this really great talk. Nice. It's always a fun listening to you. I enjoyed the other talk from 2024 very much this morning, so yeah, thanks a lot. So, are there any questions for Mitchell? Boris, do you have some? None? Okay, thanks a lot.
Thank you.
So I will hand over the mic to Carl Berry, I think, for the general meeting. Dankeschön.